Hello, everybody. Hi. How are you? I'm really sorry for this technical glitch. Hi, hello. Yes, I'm here. Hi. Hello. Hi. Good evening. Very good evening, Andariki. How are you all? Am I visible? Am I audible? Okkasari chippandi. Is everything clear? Screen and all. I hope everything is clear. Hello. Yes. 1 minute. Okay, just a minute, Andariki. I'm really sorry for the delay, but this was all the technical fault, okay? Sorry. Good evening, everybody. Good evening. Very good evening from my side. Start chedam andariki. Let us start today's session without delaying. Andariki choose. So, name is kinetic theory of gases. Yes. Your kinetic theory of gases. I think everybody is just a minute. I think again it's doing the same glitch. Right. So we will start, everybody. Okay, start Chitra. So, okay. So ఈ చాప్టర్ గురించి చెప్పాలంటే యూ హ్యావ్ యువర్ KTG, kinetic theory of gases. You see, in your thermodynamics, the chemistry lo kuda, you have the similar applications kada, anti ideal gas equations, Boyle's law, Chas law, and all those things. Okay, చూసుకోండి. Sorry. So let us quickly go through the introduction of the chapter and we will start solving the questions. అంతే కదా everybody? Okay. చూసుకోండి. So ఈ సెషన్ లో we are going to talk about gases. We talked about solids, mechanical properties of solids kada, Young's modulus, your shear stress and strain, all these things. We talked about liquids, we talked about fluids kada, yes, we talked about viscosity and all those stuff. ఇప్పుడు gaseous లో we'll talk about some terminologies లేదా hi. We are going to talk about the energy of gas molecules, pressure, momentum, temperature, volume, number of moles and all these things. చూసుకోండి. Whenever అందరికి జాగ్రత్తగా వినండి. Whenever a gas molecule whenever your discussion is restricted up to your gas. Okay. Yes. So whenever your discussion is happening on gaseous states, చూసుకోండి. You have 4 to 5 parameters. 4 parameters. Number 1, first parameter is the pressure of the gas. And you need to clear up your concepts. Okay? The first concept is your pressure of the gas. The next concept that we are going to discuss is the volume of gas. Next, చెప్పండి అందరికి. The number of moles of gas. These 4 terminologies, they are the fingerprints of a gas and they are the signature. Every gas, each and every gas has a unique single signature and a unit fingerprints and these 4 quantities. Each and every gas should have unique properties. We call these the properties of your gas. You're understanding? Sir. Now let us talk about each and every terminology one by one. చూసుకోండి అందరికి. What is pressure of gas? అందరికి చూసుకోండి. చెప్పండి. Can any one of you tell me what is the pressure of gas? What is the pressure of gas? what is the pressure of gas? What do you mean by pressure? Now feel kavalra. I want to have the feel of it. What do you mean by pressure of gas? Pressure ante enti? Cheppandi. What do you mean by pressure of the gas? What is pressure, Ra? No, not the tension in the molecules. When you talk about pressure, Ra, you need a surface. You cannot talk about the pressure of gas without talking about a surface. No, not density, not density. Idigo. Try to understand. If you have a balloon, okay, Leda, if you have a cube, you can take whatever shape you want. Choose kondi andariki. Me daggara oka balloon unte Leda, you take a cube ra. E cube or e balloon lo oka gas fill cheskundira. You take a similar amount of gas. Okay, I'm talking about the real gas. Try to understand. Andariki. There is a difference between your real gas and your ideal gas. So ippudu kosam I'm keeping my discussion restricted up to your real gases only. Real gas is low. When you are adding the gas into the sphere, lay the balloon, what's happening, sir? You blow the balloon, the gas is there. You try to press the balloon. Do you think it will be compressed? No. Why? Because these gas molecules that are there, they will try to push the surface of the balloon. They are everywhere. Randomly moving in all the directions. So they are trying to push the balloon. Yes. You can simply say, sir, this force, this force, whatever they are applying, force upon the area of the balloon. You are understanding? We will call it the pressure of the gas. And simply, pressure is nothing but the force exerted by the gas particles on the walls. You are understanding? On the walls, on the surface, whatever surface they are confined to. Try to understand. You are understanding? Sir. What about volume of gas? Try to understand. Okay? Volume gurinchi chustunna. What do you mean by volume of gas? Does a gas have a fixed volume? Try to understand that this is a basic difference. Shape and volume are two terminologies. Okay, we are talking about shape and volume. When you have solids, when you have solids, means solids kosame, you have a fixed shape. Shape fixed kada? Yes, fixed shape, not breaking ra. Fixed shape and fixed volume. But when it comes to liquid, cheppandi, liquids kosame, the shape is not fixed. You are understanding? And it will take whatever shape you insert into ra. Okay, what about volume ra? Volume is fixed. Okay, you have to see the gases from a new perspective ra. Lecture nunchi, after this lecture, try to visualize for gases whatever I am telling to you. Yes. What about gases, sir? Me gases kosam chuskondi andariki. For your gases, your shape is also not fixed. Your volume is also not fixed. Oh my goodness, what you are telling, sir? Your volume is not fixed. Yes. For your gases, your shape and your volume, they are both not fixed. Try to understand. Okay? You have a balloon, okay? This balloon, let us say you have filled some gas. Try to understand. Okay? You are filling some gas. And let us say the volume of the balloon is 1 centimeter. 1 meter cube. Let us say 1 meter cube is the volume. 1 meter cube is the volume of this balloon. This balloon, you have completely filled the gas. Yes. What I am doing, I am basically transferring it to another volume. So what did we do? We connected the shape, we connected the balloon, and we are transferring this entire gas into another balloon. You are understanding? This is another balloon. Hey. In the beginning, మొదటిగా this was empty, complete empty balloon ra, completely empty balloon, completely empty అంటే తెలుసా? Should not say balloon ra, let us say metallic sphere, okay? This is a metallic sphere. Here you go. Try to understand. You are understanding? Now what did you do? You inserted the entire gas into this balloon, and let us say the volume of this balloon over here. Andariki chuskondi. The volume of this balloon V is equals to 200 meter cube. Volume of this balloon ante 1 meter cube. When the gas was in this balloon, volume was 1 meter cube. As soon as you transfer your gas into this me gas volume changes to 200 meter cube now. Understanding? Yeah, understanding, sir. Okay, sir. So does that mean, hey, let us take one scenario, okay? Let us take one example. Choose kondi andariki. So let us say this is your cabin. Cabin leda chamber, chamber, okay? Let us talk it as a chamber. All of it. Now let us see who can answer my question now. Okay. Learning it. This is a chamber. Chamber and there is a gas. There is a pipe filled into it. Okay? So this is a pipe that's actually going into the gas, into the balloon, into the container. This is a pipe. This is your chamber, and this pipe nunchi you are flowing the gas into it. Chuskoni andariki. Slowly and slowly, the gas is getting pumped up. Kada? The gas is getting pumped up. The gas is getting pumped up. Andariki chuskoni. The gas is getting pumped up. Ante the matter అంటే the molecules లేదా the amount of gas inside this chamber అందరికి జాగ్రత్తగా వినండి ఈ chamber లో ఉంటే your gas molecules are continuously increasing కానీ what about their pressures sir molecules increasing అంటే pressure కూడా increasing ఇదే కదా yes so pressure is increasing what about number of moles this also increasing ఎందుకంటే you are pumping the gas కదా yes you are sending continuously enormous amount of gas into this chambers అందరికి చూసుకోండి so మీ pressure increase అవుతుంది your number of moles also increasing కానీ what about volume what about volume అందరికి what about volume కానీ your volume is fixed it is not changing ఇదే కదా your volume is fixed అంటే ఈ మొత్తం గ్యాస్ కోసం at each and every time you see gas is continuously adding and volume is not increasing. You are understanding? Volume of gas is not fixed. And a volume of the container is simply equals to volume of your gas. Ide kada chuskondi. So I'll write a golden statement andariki chuskondi. Your volume of container is volume of gas. Finished is volume of gas. This is the biggest breakthrough andariki vinani jagrata. So your volume of container is nothing but the volume of your gas. So if I take a gas of 1 meter cube and I pour it into this room so in case lo your volume of the gas becomes equals to the volume of the entire room whatever you are sitting into. You are understanding? We don't decide the volume by looking at the particles. Me liquids kosam we do that. I mean if your volume is more ante number of particles should be more. Me solids kosam kuda your volume is more ante your number of particles should be more. Kani me gases case lo we don't use the same approach andariki. Okay sir. So now what do we do? We will try to analyze some other parameters, okay? We will try to analyze some other parameters. So what are the other parameters, sir? Choose one. Let us talk about number of moles of gas. Here you go. What do you mean by number of moles of gas? Choose one. When you are talking about standard condition ante entira your STP standard temperature pressure condition at STP idigo at STP ante entira ante your temperature should be somewhere around 30 degrees Celsius and your pressure should be around 1 atm idigo at standard temperature pressure conditions your 1 mole of gas has 22.4 liters of volume. అర్థమైంది? అంటే ఏంటిరా, your 1 mole of gas has 22.4 liters of volume. Any gas it is, does not matter specific gas. ఏదైనా గ్యాస్ తీసుకోండి, your 1 mole of gas has exactly 22.4 liters of volume. Try to understand. Okay, sir. Next, we're talking about temperature kada? Yes. So as you're increasing the volume, right, number of moles, volume also increases. Ante kada? Yes. Now, let's talk something about your temperature. Let us talk something about your temperature. Temperature is usually taken in Kelvin, okay? Number one, your temperature must be in Kelvin. We don't talk much about the temperature. Okay, leave it only till this point. Okay, we talk about temperature in Kelvin. We talked about your volume. We talked about number of moles. We talked about pressure. Yes. Sir. Great. Let us talk something about your laws of gas. Okay, you have 4 parameters kada: pressure of volume, temperature, and number of moles. We are going to link up each of them one by one. Here you go. We are going to link up each of them one by one. Yes, sir. Just go. So, let us talk the relationship about your pressure and volume. Mudatiga. If you change the pressure, how will the volume increase or decrease? Yes. So if your link is between pressure and volume, if your link is between your pressure and volume, what will happen, Ra? You simply say, sir, if you are having a pressure and volume, they are inversely proportional to one another. There is this law, Ra. Okay, there is this law. No, I did not ignore. Yes, sorry. So this law is known as, do you know the name of this law? What do you call this law? What do you call this law? You call it as your Boyle's law. Yes. So Boyle's law. You call it your Boyle's law. Ante entira, your pressure is equals to something constant upon volume, sir. You can simply say your pressure into volume should be equals to constant. Each and every law comes with a set of examples. Okay, sir, very good. It's known as Boyle's law, and each and every question comes with a set of problems. Whenever you are studying each and every single law, you must be very good, extremely good at understanding the problems also. Okay, sorry. So let us take a question on this. And pressure P. Chip it. You're getting it? No, you don't have to study Boyle's law for practical. Why will you study? No, not to be. Depend. Girls' law. Sorry. It's not Boyle's law, right? It's Boyle's law. Okay? Boyle's law. You should say it is Boyle's law. Okay? Happy now? Boyle's law. Okay? Sorry, choose one. So you'll simply come to know that your pressure is inversely proportional to volume. Yes. That means your P is equals to some constant upon volume. We are taking the ratio on the ratio P1 upon P2 should be equals to V2 upon V1. You are understanding? You are understanding? Sorry. Okay, sir. Now, when you are P1 by P2, P1 and ఏంటిరా? Pressure is P కదా? చూడండి. Pressure is P. Pressure is P divided by P2 అంటే let us say P dash. నాకు P dash value కావాలి కదా? Yes. V2 చెప్పండి ఒకసారి. V2 అంటే ఏంటిరా? Volume of sphere, volume of balloon, volume of sphere అంటే volume of balloon. అంటే your volume is 4 by 3 pi r2 cube divided by 4 by 3 pi r1 cube. ఇదిగో 4 by 3 pi, 4 by 3 pi gone. Understanding? అంటే your pressure upon P dash should be equals to R2 cube by R1 cube. R2 cube is what? Your sphere is shrunk by half radius కదా. చూసుకోండి. Your R2 is nothing but R1 by 2, right? It has been shrunk by a factor of 2. ఇదిగో. You at least need to practice 5 to 10 questions per law. Hey, your entire KTG is completely filled with this type of examples. Understanding? Even your PYQs. Yes. Okay, Nandini, physics practical. Next, your R2 value is simply equals to R1, but substitute, sir. R2 by R1 cube. So you will simply say, sir, P upon P dash is equals to R2 upon R1 whole cube. R2 upon R1 whole cube. Substitute the values of R2. Your R2 is simply equals to R1 divided by 2 divided by R1 whole cube. So R1 gone. So here P upon P dash is equals to 1 upon 8. Directly also choose one in the very good. Inverted, sir, your P dash divided by your pressure P is equals to simply 8. That means your P dash should be equals to 8 times of pressure. Try to understand. Your pressure is changing with the volume, not with the areas. Understand, okay? This is a very obvious law. Kani, if you try to dissipate it, and if you try to link it with area, you'll be gone. Understanding? The same thing could be applied even for cubes also. Instead of this sphere, if a cube was used, let us take the new question. Okay? Same thing. A gas filled in a cube at pressure P. Idigo. At pressure P. Ide kada? Yes. If edge, I should say edge of cube half, find new pressure. Same. P1 by P2 is V2 by V1 kada. Same, ditto same. Choose your P1 divided by P2 should be equals to V2 upon V1 whole cube. Hey, V2 upon V1 kada? Yes. What is V2, sir? It is a cube. Cube unte your volume of cube is simply equals to edge cube kada. Ade. Substitute చేసుకోండి V2 అంటే సార్ L2 cube divided by L1 cube అంటే you can simply say L2 upon L1 whole cube directly చేసుకోండి. So you are simply say P2 is 8 times P1 here also and here also. Understand? Because the volume is to the power 3. Understanding? Length cube లేదా radius cube. You understand all these things. Sir, very good. So one is a case of compression, another is a case of expansion. Expansion and in expansion your pressure decreases. You are understanding? And the volume is increasing. So if the gas is expanding and the volume is increasing. If volume is increasing, pressure decreases. Okay. Sir, next. In your next case, okay. So in your next case, what we are going to do is we are going to discuss about Charles' law. Okay. Sorry. So your Charles' law ante enti ra? It simply tells about volume and temperature. Andariki. Your relationship between volume and temperature ante endira. Your volume is directly proportional to the temperature of the gas. Andariki. You understand? So, volume is directly proportional to temperature. Ante endi sir? If your volume V1 divided by V2 is equals to T1 divided by T2. Idigo. The biggest mistake that the students do in this case, they take the temperature in degrees Celsius only. No, and you are understanding your temperature must be in Kelvin. Try to understand. You are understanding? Sorry. Now, let us take one more case. Choose one. A gas at 27 degrees Celsius has depend. I'm telling you, whenever you are given the relationship between your volume and temperature, be careful. Take your temperature in Kelvin, not degrees Celsius. Okay. Hi. Good evening. Sorry. So you'll simply say V1 upon V2 is T1 upon T2. You can do it by yourself. Okay. You must be very good. You must be very good at solving. There is no question at all. You have these in 2 different subjects. And thermodynamics is there in your chemistry also, in your physics also. So you must be extremely good at this. You are understanding? Extremely good. Okay, I'm reading the comments. Okay. Thank you so much for these efforts, చెప్పండి. I want the answer only. అదే we are forgetting something, okay? We are forgetting something. We are forgetting about the graphs. The question is there in 2024 about the graphs. So let us talk something about your graphs of Boyle's law. Idigo. When we are talking about the graph of your Boyle's law, pressure inversely proportional to volume kada. Try to understand all of it. Pressure inversely proportional to volume. Ante this is the graph. Ippudu chudandi, okay? This is your pressure. This is your volume, ra. First graph. Understand? The question that is asked, Leda, the type of question that you will be asked is something like this. Choose one. You have three different graphs. And this is your first graph. This is your second graph. This is your third graph. Andariki. And when we talk about your Boyle's law, your pressure is inversely proportional to volume, kada? Yes. Here. It is understood that the temperature is constant. There you go. You're understanding? When we talk about your Boyle's law, we only talk it at a constant temperature. Right? It is the biggest condition that you should understand. You're understanding, sir? And in case lo, leda ee graphs lo, chudandi. Moodu graphs unnai kada. So these are three different conditions. Ante three different temperatures. There you go. E and there, is your temperature 1. This is your temperature 2. This is your temperature 3. Ide kada. What do you do now? If the questioner asks you which of the following has more temperature, ante option A, your T1 greater than T2 greater than T3. Leda T1 less than T2 less than T3 ra. You're understanding? Option C is T1 is greater than T2 is less than T3. Leda option D is T1 is less than T2 is greater than T3. Cheppandi. What is the relationship between the temperatures? Okasari graphs ni chudi here. Just go. Not talking about the depth of this topic, sir. Just once you have the graphs, you will have to talk about which temperature is more. So how will you do it? Whatever graph it is, try to understand how to solve these questions. You do one thing. You directly plot a vertical line. Finished. You want to draw a vertical line? Leda vertical line. If you want to draw a horizontal line, you can draw a horizontal line. It's all up to you, ra. Draw a vertical line. Leda draw a horizontal line. Ide kada? Yes. Draw a vertical line. Leda draw a horizontal line. Now, when you are drawing a horizontal line, choose coding. What's happening, ra? You are getting some points of intersection, kada? Yes. So this is your first point of intersection, second point of intersection, third point of intersection. Choose code. Now drop the perpendicular from the points of intersection. And this is your first perpendicular. Ide ante me second perpendicular. And this is your third perpendicular. Choose code. Draw it. Draw perpendicular. Then take the volumes. Your volume V1, volume V2, volume V3. Cheppandi. Which is more and which is less? V1 is less than V2 is less than V3 kada. We are going away. Ide kada? Yes. So if you are V1 less than V2 less than V3, you have to talk about temperatures. Okay? Temperatures. That means your volume is directly proportional to temperature. Idigo. Your V1 less than V2 less than V3 and your T1 is also less than T2 is also less than T3. Idigo. This is how you take the relationship between the temperature and the volumes. Andari. Jagrataga chudandi. Okay. Hi. Hey, try to understand everybody. Okay, sir. So once that's done, I want you to do this question. Cheppandi. 27 degrees Celsius kada. Radius R. New temperature is 327 degrees Celsius. What do you use? You will use Charles' law. V1 is directly proportional to T1. V1 upon V2 should be equals to T1 upon T2. Ide kada? Yes. T1 upon T2. Substitute T1 value unta sir. T1 is 27 degrees. What is T2 sir? T2 వాల్యూ చెప్పండి ఒకసారి. T2 is 327 degrees Celsius. ఇదే కదా. This is your V1 upon V2. V1 is what? 4/3 pi into R1 cube divided by V2 చెప్పండి. 4/3 pi R2 cube. Gone. Let's see it. That means your R1 cube divided by R2 cube is equal to 27 divided by 327. Is it correct or not correct? Correct or not correct? Not correct. Not correct. Wrong. That's a mistake. Enduku sir? Enduku? Because ఈ కేసులో టెంపరేచర్ చూసుకోండి ఒకసారి. డిగ్రీ సెల్సియస్ కదా. That is the twist. Your temperatures should not be in degrees Celsius. They must be in your Kelvins. You are understanding? Ante me temperature 1 should be equals to 27 degrees Celsius. Ante 300 Kelvin. Ardhamindi iddariki. How will you do, sir? Add 273 ra. Conversion. What's happening today, ra? 27 degrees Celsius. And 273. ఇదిగో 300 Kelvin. చెప్పండి temperature T2 is 327 degrees Celsius. At 273, it becomes 600 Kelvin. ఇప్పుడు use these values of temperature. Okay? Substitute these values. అంటే your R1 upon R2 whole cube రా. ఇదే కదా డైరెక్ట్లీ అందరికి చూసుకోండి. your R1 upon R2 whole cube is equals to 1 upon 2. అంటే 300/600 కదా. 300/600. Good. Very good. So ఇక్కడ నుంచి you can simply say that your R1 upon R2 should be equals to 1 upon 2 to the power 1/3 రా. Cube roots kada. Cube roots. So you will simply say, sir, your R2 should be equals to 2 to the power 1/3 times of R1. Very good. It's a very good question. అర్థం వచ్చింది. Not root 2 రే baba. It's not root 2. It's cube roots kada. So R2 should be equals to R1 into cube root of 2. Not square root. It's a very minor difference, okay? Sorry. Hi. Hello. You want? Let us talk about graphs. Let us talk about the graphs. చూసుకోండి అందరికి. So VT graph kada? Yes. So V and T ra. ఇదిగో. Your V is directly proportional to T and V should be equals to K into T. If your V is in Y axis, K into X. ఇదిగో Y is equals to MX form kada. And all of your graphs will pass through the origin. Try to understand everybody. Your all graphs, నీ మొత్తం graphs, they are going to pass through the origin. Something like this. ఇదిగో. These are the terms. Now, again the same condition comes into the scenario. What is the condition? This all is valid. It is understood that your pressure is constant. And at constant pressure, your volume is directly proportional to the temperature. Adham cheskondi. Ee case lo it is telling you that this is a graph. First line ni chuskondi. First line at temperature P1, second line at temperature P2, third line at temperature P3. Cheppandi, what is the relationship between P1, P2 and P3? Ide kada? Yes. Can you tell me? It is there in 2024, okay? Same question, same. 2024, NEET 2024. What to do? Same thing. What same thing, sir? Draw a horizontal line. Draw a vertical line. It's all up to you. Whatever you want to draw, you draw it. I'm drawing a vertical line. Okay, sir. Once your vertical line has been completed, Mari em cheyali? Take the intersection points. Ide na first intersection. This is my second intersection. This is my third intersection. In intersection points nunchi drop a perpendicular. Yes. Drop a perpendicular. Idigo. Perpendicular kada? Yes. Drop a perpendicular. Vachindi kada? Yes. These are your perpendiculars. Now see the values of volume, ra. See the values of volume. And this volume is V1, ikkada vachi V2, this is V3 kada. చూసుకోండి మీ ఫస్ట్ ప్రెషర్ గ్రాఫ్ కోసం వాల్యూమ్ ఇస్ V2, మీ సెకండ్ గ్రాఫ్ కోసం వాల్యూమ్ చూసి ఇట్స్ V2 సారీ V1 V2 అండ్ థర్డ్ ప్రెషర్ అంటే V3 వాల్యూమ్. What is the relationship between V1 V2 V3 ra? Your V1 is less than V2 is less than V3 ఇదే కదా. చూసుకోండి they are going up అంటే pressure will be reversed. ఎందుకంటే they are inversely proportional. Inversely proportional ఉంటే you will simply say your P1 is greater than P2 is greater than P3. అంటే ఏంటిరా? That means if you have a VT graph of any curve, చూసుకోండి అందరికి. If you have a VT graph of any curve, జాగ్రత్తగా వినండి. When you go in the clockwise direction, pressure increases. Clockwise direction అంటే ఏంటిరా? What do you mean by clockwise direction? Your graphs of the pressure, చూసుకోండి. Your VT graphs, if they are shifted, something like this. ఇదిగో 1, 2, 3, 4, 5, 6. We are going in clockwise direction. You are understanding? అంటే if you are asking about P1, this is your P2, P3, P4, P5, P6. Try to understand. Go clockwise. Hey, P6 to P5, pressure increases. P5 to P4, pressure increases. And P1 is at highest pressure. Understanding? You are understanding? So, you will simply say that your pressure conditions are P1 greater than, P2 greater than, P3 greater than, P4 greater than, P5. There you go. Finished. These are your conditions. Later P6 also. You can add P6 into it. Otherwise, yes. Your Charles law has been completed. You try to understand everybody, okay? If you want, I will write the PYQ also, but it is the same PYQ. The following graph represents TV curve of an ideal gas at 3 pressures P1, P2, P3 compared with those Charles law. Those of Charles law represented as dotted lines. Sorry. I write this question, Andariki. The question is there in NEET 2024. The following graph represents TV curves. you can do it. The break will be at 8:30, okay? 8:30 to 8:30. Let's take a break at 7:30 itself. Not 7:30, ra. Let us take a break at 8. 8. Values తీసుకోండి. Values. P1, this is P2, and this is P3. Very simple questions, ra. Why are you taking so much of time, sir? Should be done in a blink of an eye. No, you only have 60 seconds of time, ra. Okay. Class duration will be till 10 p.m. or 10:30, depending upon the condition. Anyway, I have become half an hour late, ra. Okay, so that was the problem. What is not understanding? Sorry. So how to do it, ra? You forget about these curves, ra. They're not useful for us. Choose. These curves are not useful for us. If you want to do it, you can do it. How to do that? Draw a vertical line, horizontal line. You do whatever you want. Draw a vertical line or a horizontal line. Okay, I'm drawing a horizontal line. Here you go. And the line should cut all three of the pressure points. Okay, like this. Something like this. Try to visualize. And then, intersection points. What are the intersection points, ra? This is your first intersection point. Choose go. Can you see this graph? Hey, all of you, this is the graph. Okay, this is dotted lines. So here is the point of intersection. First point. Second point, chudandi. This is the second point of intersection. It is visible. And third point of intersection is somewhere here. Here you go. Not perpendiculars. Perpendicular. Cheppandi. So this is your first perpendicular. This is your second perpendicular. This is third perpendicular. Volumes cheppandi, sir. Volume V1, V2, V3. What is the relationship between the volumes, ra? Definitely, kachitanga, your volume V1 is less than, V2 is less than V3. You're understanding? Am I drawing? Yes, correct. What is the relation between pressure and volume? Inverse. Inverse unte, your pressure P1 greater than P2 greater than P3. Ledante, if you want to draw a vertical line, I draw horizontal. Kada? So some of you say that I draw vertical, my answer is not getting right. Choose. This is your vertical line. Now, points of intersection. This is your first point of intersection. This is second point of intersection. This is your third point of intersection. Now, draw perpendicular. So your perpendiculars will be like this, like this, like this. What is this? Temperature. What is this? Temperature. Temperature value T1, T2, T3. What is the relationship between T1, T2, T3? I'm doing mistake. See, corresponding graphs kavali kada. This is a graph of P1, P1. Intersection choose P1 and this is T1. P2 is here and P2. Choose P2 is here and temperature T2. P3 is here under temperature T3. Cheppandi. What is the relationship, sir? T1 greater than T2 greater than T3. What is the relation between pressure and temperature? Directly proportional. Directly proportional ante your P1, P2, P3. What derivations, ra? You don't need derivations. Hey, are you preparing for G advanced, ra? You don't need it. Sorry. So Boyle's law, Charles' law, completed kada? Yes. Now, let's talk something about the next law. The next law is, don't laugh, hey, the next law is good. I know, that's some creative minds. That creativity is useless, kind. What will you do with those creative minds? Your creativity should be useful creativity. Yes. So, it talks about your pressure and temperature. Pressure and temperature relationship. What is the relationship between your pressure and temperature? Directly proportional. Finished. Okay. Right. Directly proportional. At the end, sir. That means, hey, again. When I'm telling this, your volume should be constant. Okay? Try to understand. These are the boundary conditions. Ante me volume is constant kavali. Then and only then you can say that your pressure is directly proportional to your temperature. Okay, sir. At the end, sir. Your P is equals to some K into T. That means your P1 is K into T1 and your P2 is K into T2. You understand? Hey, there was a teacher. I'm telling you, when I was in my JEE preparation. Okay? Our chemistry teacher, he was telling that, hey, I'll tell you, I'll tell that story later on. First, let us talk about this. When I talk about ideal gas equation, then I'll tell you. Right? So, you'll simply say your P1 upon P2 should be equals to your P1 upon P2. This is the important conditions. Boundary conditions are the important conditions. Whatever you want to say, you'll say it. Sir, next. In your next scene, we will be discussing about the graphs. Graphs, kada? Yes. So, let us talk about your graphs. This is your pressure. This is your temperature. Yes. The graph will actually be a straight line. Once again, choose one. Your graph 1 is here. Your graph 2 is here. Your graph 3 is here. Yes. Try to visualize. Right. So, the parameters parameters ante your pressures pressures P1, P2. Hey, pressure, temperature, volume should be constant yes. So volumes are the parameters. Andariki chooskondi. Ide me volume V1, volume V2, volume V3. Ante kada. I want to find the relationship between the volumes V1, V2, V3. Cheppandi. How will you calculate the volumes? Same thing, Ram. Same thing. Drop the perpendiculars. Finished. Ante. How will you find the volumes, Ram? Cheppandi ukasari. You will simply drop the perpendiculars from the perpendiculars. Draw a straight line, a horizontal line, leda vertical line, depending upon the situations. Hi. Sorry. So how will you do that? You draw a straight line and it should either be horizontal or it should be vertical. So if you want to draw a horizontal line, draw it. Vertical line, draw it. So I'm drawing a horizontal line. Hey, horizontal line. Find the points of intersection. This is your first point of intersection. Your second point of intersection is somewhere here. And this is your third point of intersection. Yes, draw the perpendicular. Hey, when I'm saying perpendicular to the line that you have taken, okay, not on axis. You're understanding? The biggest problem I face is everybody comparing me with this hero, this movie, that movie. Hey, what should I do that? I'm a human being. Sir, anyways, but that's your love, okay? I'm really grateful for that actually. Thank you so much. Okay, thank you so much. Anyways, so let us say the temperature is T1, here temperature is T2, here the temperature is T3. Ochindi kada? Tell me the values. The relationship cheppandi okkasari. Temperature relationships. Sir, your temperature T1 is less than temperature T2 is less than temperature T3. Naku volumes kavali kada. Ippudu chudandi the relationship between the volumes now. You will simply say, sir, your temperature directly proportional to volume. Which law ra? Charles law. Charles law. Ade. So if your temperature 1 is less, ante your volume 1 less than volume 2 less than volume 3. Idigo. Finished. Ochindi kada? Sorry. So these are the volumes. Okay. Volume V1 is less than V2 is less than V3. And V3 is greater. Chudandi. In the last case, when we were discussing about your Charles law, andariki, in your Charles law, you are going clockwise. Pressure was increasing. Ade kada? Yes. Kani, in case law, when you are going clockwise, what is happening? Volume is decreasing. Idigo. Want to remember this way? Remember this. It's a shortcut, and you will understand very quickly. You don't keep doing all these things. Go in the clockwise direction, volume decreasing, V1 is less than V2 is less than V3. Finished. You can do it by directly. Just remember the arrows. Okay. Sorry. Next, let's talk about last law. Last law, and then we'll try to combine the laws. Okay. Just one. Your last law is. Do you know the name? Do you know the name of the last law? The name of the law is Cheppandi. What does the law say about? Hi. Hello, everybody. Hi. Yeah, Avogadro's law talks about the relationship between your volume and your number of moles. You are understanding cardiac temperature. Constant pressure, constant temperature. And then choose one. Your Avogadro's law talks about the relationship between the volume of the gas and the number of moles of the gas. Kani, okate condition matrame undali. What should be the condition, sir? Your pressure and the temperature must be same. Okay. You try to understand, Ra. If you have the equation, sir, 2y is equals to 6. You will simply say y is equals to 3. Very easy equation. Everybody is understanding. Okate variable untadi kada? Yes. If the variables are double, you will have to do double work. If the variables are triple, more work. If the variables are 4, even more work. You're understanding? And these 4 variables will confuse you like anything, Ra. You will be gone under the pressure of 4 variables. You're understanding? The same thing will happen over here now. Try to understand. When you are doing any experiment you do it, you will see that all the parameters of the gas are changing. I'll tell you at the end. Kani, let us try to understand these things. Okay? Choose one. So that means your volume V1 V is directly proportional to N kada? Yes. So your volume is directly proportional to number of moles. And your V should be equals to some K into N. That means V1 upon V2 should be equals to N1 upon N2. Now we'll be talking about the combinations of the laws. Okay, combinations of the laws. And I am writing all the laws over here. Not the names, directly equation has to choose code. So pressure is inversely proportional to volume. Number 1. And P is equals to some K upon volume. Yes. Pressure is directly proportional to temperature. And P is equals to some K into temperature. Next, your volume is directly proportional to temperature and V is equals to K into temperature. Last law, Cheppandi, your volume is directly proportional to number of moles and V should be equals to K into N. If you have to take any 2 laws at a single time, what I'm telling, if at all you have to take any 2 laws at a single time, Ra, how will you do it? How will you merge it, Ra? So let us say I want to talk about these 2 laws, Ra. So here I'm talking about these two laws. At one time, and okay, time law, I'm talking about these two laws. And the pressure is K upon V, pressure is K upon T. Yes. How will you do it? How will you do it? Or else, let us do one thing, right? Okay, let us do one thing. Let us merge this law and let us merge this. Yes. So how will you do it, sir? Cheppandi. Take the left side quantities in the left side. Take the right side quantities in the right side. Am I wasting my time, Ra? Nobody is interested. Let it be. Merge all of these equations together. When you merge it, you'll come to know that your K value. Cheppandi okasari. So, sir, your PV is equals to K. Your P is equals to K into T. Here, V is equals to K into T. And your V is equals to K into A. Left side, cheppandi andariki. Left side, PV, P, V, V. All are already there. And in the left side, you have either pressure or volume or both. Yes. Right side cheppandi okasari. Sir, me right side lo you are having only K, leda KT, leda KT, leda KN. And K is there, kada? T is also there, and N is also there. Here you go. This constant K in this scenario is a special universal constant. Universal constant in Indira, its value is fixed at each and every point in the entire universe. So, this constant K is known as universal gas constant. And the short form is R. Ante you will simply say, sir, your PV should be equals to N into R into T. Your R value is 8.314 లేదా 0.082. Andari చూసుకోండి. This is SI value. SI value ante when your energy and all these things calculations are to be done, so you will use this value. Leda, your atmospheric pressure and all those things. ATM. Pressure unit ATM lo unte use this. Pressure unit Pascal lo unte use this. You understand? So, next. Try to understand. Andariki. We are telling something about what should I say? Experiment on the same gas, right? Experiment on the same gas. That's why I was telling to you. You have 4 different variables: pressure, volume, temperature, number of moles. 4 variables, kada? Yes. If you have a same gas and Indira, you try to understand. This is your chamber, all of you. These are very, very, very important, highly important topics. Andariki. I want all of you to focus here like anything. Okay, Cheppandi. So if this is your chamber, hey, all of you, try to understand. Now what you are doing is, you are heating this chamber. Pressure, hey, before heating, the pressure was P1. Volume is going to change. Yes, let us say volume is also variable in the V1 and temperature is T1. Here we go. Heat chasina tarvata, heat, not hit, okay, heat chasina tarvata, the volume has increased. And there is expandable chamber. Yes. Let us say here the pressure is P2, volume is V2, temperature is T. What is the relationship? Yes. What is the relationship between the two chambers? Cheppandi okasari. You will simply say, sir, your relationship is simply like this. Choose one. Number of moles N, they have not changed. You must understand what is changing and what is not changing. Pressure changing, volume changing, temperature changing. And number of moles? No. How will the number of moles change? They will only change when you add or remove the gas. You understand? So no gas has been added. Alage, no gas has been taken out. And the total number of Moles ante constant quantity ide kada. Yes, ikkada kuda n ante number of moles. Here also your number of moles are n only. Ideal gas equation cheppandi okasari. Your ideal gas equation is PV is equals to n into R into T. Idigo your number of moles are constant. Anyhow your gas constant is also constant ante ee mottam quantity becomes constant. Certain temperature, that's it. Ante PV divided by T must be equals to constant quantity K. ఈ constant value ఏంటంటే n into R అందరికి. సో ఈ కంటైనర్ కోసం ఒక్కసారి PV upon T క్యాలిక్యులేట్ చేసుకోండి. Same thing for this container also, sir. PV upon T and they must be same ra. ఎందుకంటే number of moles are same కదా. Yes. What is the doubt చెప్పు. So you will simply say, sir, first container ఉంటే P1 V1 upon T1 should be equals to second container ante P2 V2 upon T2 ide kada. So the equation that you will be writing is P1 V1 upon T1 should be equals to P2 V2 upon T2. Idigo. This is only valid when your number of moles are same. Okay, when your number of moles are same. Vachindi kada. Now ఇప్పుడు this equation you can simply say, sir, this is applicable when experiment is done on a same gas. Will you do it? So let us take a question. I think it has been asked in 2025. 2025, what is the question? No, you don't have any question as such. Let us take a question by ourselves. Okay. Next, hey, let us take a question. A gas. I will give you 5 minutes time. Not 5 minutes, 2-3 minutes this one. You have to take a break. Yes, what is that, Nandi? What are you telling? Just hear this. It's all right, Kada. Why are you telling to adjust the camera? It's not in my hands, Ra. These are the technical glitches. Due to the camera problem only, I started the lecture half an hour later. You know, if I do something, it'll be gone. The lecture will be gone. Okay? Let us see. 33.33%. Gas filled chamber. Kada? Simple formula. Ra. Let us say pressure is P. Initial pressure, I did not give that. I did not give. Ade, in examinations, they don't give the terminologies and ask changes into percentage changes. They ask. Okay? They will ask always percentage changes. Sorry. So now P into V1 upon T1 should be equals to P2 V2 upon T2. How will you use this formula, sir? You must be very good at expressing the formulas later using the formulas. So let us talk about the formulas. P1 is P, V1 is V divided by T1 value cheppandi 300 Kelvin kada. Yes, should be equals to P2 is P dash, V2 is double the volume at 2V divided by 127 kada. 127 and 400. Idigo 0 0 0 0 V gone. What you are left with is your P upon 3 should be equals to 2 1s are 2, 2 2s are 4 kada. Yes, so you will simply say your P dash divided by 2. Ekkada nunchi your P dash value cheppandi okasari. Your P dash is nothing but 2 upon 3P. Ide kada. You are understanding? So this is your P dash value. Chindira andariki. Percentage P kavali kada. Yes, percentage change in P is equals to what will you say, sir? Sir, it is P initial minus P final by P initial into 100. Andariki cheppandi. So your percentage P should be equals to P initial is 2 by 3 minus P final. P initial is P, P final is 2 by 3P divided by P initial is P into 100. Choose P gone. Ante 1 minus 2 by 3 whole multiplied by 100. Ante 1 by 3 into 100. That is equals to 33.33%. Very good. Very good. Okay. Percentage change in P is equals to 33.33%. Very good. Very good. Very good. Yes. Yes. Sorry. Next question. Andriki. I'll not say question. Let us go to different forms. Forms to them. Try to understand. So, various forms of your ideal gas equation. Choose. Forms of your ideal. Not going into the derivations, Nandini. Okay, I'm just giving you the formulas. Finished. Okay, we are not going into the depth of the formulas. Number one, when it is at the macroscopic level and entira, you have billions and trillions of particles into it, and a number of moles have been given. Understanding? And Avogadro's number 6.022 10 to the power all this. So if you have n moles, try to understand. moles kada, yes, n moles. E n moles kosam you will be using another formula. That is same formula. What is the formula, sir? Your formula remains PV is equals to n into R into T. Idigo. What is the relationship between an atom and a mole? What is the relationship between an atom and a mole? An atom and a mole. You need zoom out, ra. Let us see. I don't know. I really don't know what will happen. You will be responsible, Andariki. If the video goes out, then sorry. Is it visible now? I think it's visible. Oh. The problem is not with the screen now. The problem is with the software that I'm using. I'm now able to sort it. Just one. You take it up. I think now it's visible. Okay, he should have told me this. No zooming, no zoom. Yes, I think now it's working now. Fine. Is it fine now? Andariki cheppandi okasari. Direction. I did not see the comment. I'm really sorry. Anyway, I think it's now clear, right? Clear? Not clear? Okay, fine. Is it visible, all of you? Or do I need to do much more? Okay, thank you so much. Thank you so much for the correction. Sorry. Or do you want me to elongate the screen more? I can do anything, okay? Sir. 5 ohm. Okay. Done. So this is for n moles, ra. What is the relationship between your moles and atoms, ra? Choose code. Your number of moles should be equals to n multiplied by Avogadro number. Atoms, kada? Yes. Finished. You're understanding? Your 2 moles and your 2 into Avogadro number atoms are there. This is the relationship. Understanding? Now use the same relationship here also, ra. So what will you do for n atoms, ra? So naku atoms kavali kada? Yes. What do? Divide the number of moles. Substitute. So sir, the same formula. And your P into V should be equals to, in a place of n, write this. You understanding? Sir, n multiplied by na into R into T. Here you go. Able to get it? Vedantu, what you will say, sir? You will simply say your n atoms, your n atoms is equals to, can I simply say your n moles divided by Avogadro number, Na. So if you want the formula for atoms, divide the number of, I think I did a mistake. Yes. So if you want the formula for atoms, the same formula, PV should be equals to atoms. ఇప్పుడు atoms కావాలి కదా. So divide number of moles with an Avogadro number into R into D. ఇదిగో. ఇప్పుడు this quantity over here, R upon Na is equals to K. K అంటే ఏంటి, sir? Your K is simply Boltzmann constant. And ఏంటిరా? So if you have a molecule, లేదా if you have 2, 3, 4, 5 molecules with the atoms, you use this formula. Formula ఏంటిరా? Your formula is PV should be equals to N into K into T. ఇదిగో. Understanding? చెప్పండి, ఏదైనా డౌట్స్ ఉంటే చెప్పండి. Class duration might be there till. Oh, Abhinav, I got it. Okay. The class duration will be till 10:30. Okay, 10:30. Okay. 10 or 10:30, mostly by 10 or 10:30. చూసుకోండి. Your PV should be equals to NKT. Your K అంటే Boltzmann constant value తీసుకోండి రా. This mouse ring. Your K value is 1.3 into 10 to the power minus. Yes. NEET also helps in your MSET exams, ra. Okay, but the only condition is that you need to prepare very accordingly. You understand, sir? Anyways, you want to use it. Either you want to leave it. It's all up to you. Okay. Next topic, choose one. Next variation in your ideal gas form. PV equals to nRT kada? Yes. What is V, ra? Volume. I want to express in terms of mass. Cheppandi. I need to introduce one more constant. Density is mass upon volume. And volume is mass upon density. Ide kada? Lift, shift. So your P into mass upon density equals to number of moles into R into T. Ide kada? Try to understand. If you have 1 mole of gas, 1 mole gas unte 1 mole gas kada? Yes. For 1 mole of gas, P into N upon RT ra. Understanding? You simply say, sir, your PM is equals to rho RT. What is M, sir? M ante mass of gas in 1 mole. 1 mole. Enduku 1 mole, sir? Because we have taken the value of N as 1. Mass of gas in 1 mole. 1 mole mass of gas, ra. 1 mole mass of gas ante molecular mass. You're understanding? That is the mole concept, ra. Basic, I want to teach chemistry. You're understanding? Sorry. That is your molar mass. Leda atomic mass, whatever it is there. Okay. Molar mass of gas. In grams. It should be in grams. Okay. It should be in grams. Then only you talk about it. Kada? If you have 1 mole sodium, what will be the mass of 1 mole sodium? 23 grams. Why, sir? Because it's the molecular mass of sodium. Take the molecular mass in grams. Atomic mass of sodium. The molecular mass of gas in grams. Yes. Next, right? You have all these forms. You can extract whatever form you want and you can do it. Now, let us see one last topic and then let's go to the break. Okay? Let us talk something about mixing of gases. Right? So we are talking about mixing of gases. Let us say I have 2 chambers. Each chamber your gas is there at temperature T1, pressure P1, volume V1. You are understanding? In a chamber of gas, you have a gas at volume V1, pressure P1, temperature T1. The second container also you are having the similar conditions and pressure P2, volume V2, temperature T2. So you will simply say, sir, this is my first condition. Kidney. Okay, your kidney. Let us study human anatomy. I usually get confused, I don't know the words. Anatomy, autonomy. What is correct, ra? Anatomy is correct, right? Yes. Anyway, sorry. You have your first gas. Everybody. Pressure P1, volume V1, temperature T1. Yes. Take the second gas also. Hey, this is the second gas. Kidney. Hey, this is first kidney. Hey, this is second kidney. Okay? Yes. First kidney, second kidney. Pressure P2, volume V2, temperature T2. What we are doing is try to understand. Hey, in the discussion that I am doing, sometimes it may be possible that I am speaking something that I should not speak. Okay, so forgive me for that. Okay, the students who love biology, they'll kill me, sir. How dare you draw 2 different kidneys like this? Anyways, sorry. So what you are doing is try to understand when you are mixing these two gases. Mixing and intira, they are connected with a you say, what do you call it, Ray? What do you call it? The connecting button. Hey, what do you call it, Ra? I am not able to recall it. Okay. Hi, whatever. Gauze, okay? Gauze. Connected. And then the gases are separated. They are separated before. What you are doing is you are removing this cork. You are removing it. You are removing. After you remove it, what's happening? The gases are getting mixed up. Kada? So do you think the pressure will change? Final pressure. Do you think the final temperature will change? It will be T1 or it will be T2 or it will become T1 plus T2 by half. By 2. You understand? So, this condition kosam maatladalante you try to understand ra. I can certainly comment on some things. Some things that entira. If you are talking, sir. If N1 is the number of moles of this gas, N2 is the number of moles of this gas, and when you are mixing them, net number of moles becomes N net should be equals to N1 plus N2. Array, for sure, right? Hey, chuskondi. This is the number of moles. Next. Do I comment on something? Yes, you also know one more condition, Ra. Cheppandi. Your net volume also becomes V1 plus V2. Ide kada? Yes. Ante, your net volume is V1 plus V2. Idigo, the basic understanding of the volume of the gas. Ante enti, your total volume of the gas is nothing but the volume of the region in which the gas is constrained. Ide kada? Yes. So, in case lo, can you tell me, sir? Pressure, volume, temperature, P1, V1 upon T1 ante N1 kada. Yes, so you'll simply say, sir, N net is N1 plus N2 kada. N net formula cheppandi okkasari, sir. P net, V net divided by temperature net should be equals to N1 value entira. Your P1, V1 upon T1 plus P2, V2 upon T2. Idigo, finished. You're understanding? This is your formula. Try to visualize. I am just taking the applications, okay? I am just substituting the values. N net value ikkada. N1, ide N2. Ippudu, let us use this value also, Ra. Which value, sir? V net is equals to V1 plus V2. Idigo. We are using this value also. Substitute cheskoni cheppandi. So your net pressure into V1 plus V2 divided by net temperature should be equals to P1 V1 upon T1 plus P2 V2 upon T2. Idigo. You understanding? This is the net equation for that. Vachindi kada? Yes. So let us take a question also, Ra. Let us take a break after that. Okay? Half an hour break, then we'll take it again. So a question teeskondi. Two gases. Hey, do you have a PYQ actually based on this concept? Let us see if you have it or not. Hey. I think there are some questions actually, but there are there, but we will take it after break. Not commenting on temperatures. Do it. Okay? Do it. Let us see the solution after the break. Okay? Let us see the solution after the break. Anybody tracking the time, Ra? All of you are tracking the time only. I'm back. Okay, I'm back. Give me 1 minute. I'm drinking water. Okay, sir. Sorry. Okay. Hi. Hello, everybody. Hi. Anyways, so let us see the solution, Ra. Solution after the break, so break complete, Ra. So let us see the solution. Choose good. It's a very elementary question, actually. Everybody of you must be able to solve this question. Choose good. As soon as you remove the cork, Ra, it's gone, kada? Yes. And then the moment you remove it, what is happening, sir? The gases are getting mixed up. Kada? Temperature same untundi. I've given you that the temperatures are same. Ante enti ra? Here P1 V1 upon T1. Leda number of moles are adding up, kada? Chuskondi. Hey, all of you. So you simply say the net number of moles is equals to N1 plus N2. Ide kada? Hey. P net. Hey, V net upon T net. And choose T1, T net, all they are same. T1, T2, T net are same. Unte this gone. Yes. Now you will simply talk about the net pressure multiplied by net volume. This is 20, this is 30. 50 liters kada. The gases are getting added up. And the volumes also get added up. And 50 should be equals to P1 V1. Cheppandi P1 V1 value indira 200 plus P2 V2 value cheppandi 600. Ide kada. So P net into 50 is equals to 800. Ante here P net is equals to 800 divided by you understanding? If your answer is right or wrong, how will you come to know? Your final answer should be between the two answers. And your final pressure should be between this and this. Just 10 and 20, 16. Between your correct. Good. Very good. Yeah. Sorry. We'll talk about your main chapter in the sense kinetic theory of gases. The kinetic theory of gases law will be majorly focusing on the pressure, energy, kinetic energy. That's it. Yes. Sorry. So we will talk about your kinetic theory. Choose one. Kani, before discussing the theory, there are some postulates. Postulates and enti. You see, if you have the real gas and whatever is going on in the real life, nobody knows the equations, nobody knows what is going to happen next. You're understanding? Kabatti, we designed a system. We design our own system. Our system will define some rules. Our rules and postulates. Yes. So our gases are not going to be exactly like your ideal gases. your understand your real gases, ra. You're understanding? Ante we'll be talking about our ideal gas. You're understanding? Sorry. So there are some postulates. Postulate number 1, andariki chuskondi. Postulate number 1 is when you talk about gas, ra, whenever you are talking about your gas, the size of the gas molecule should be negligible. You're understanding? Ante your first postulate is the size of a gas molecule should be negligible. Oh my goodness. As compared to you're understanding this? Ante enti sir, in your real gas, me real gas case lo, what is happening? This is your gas particles. These are all of your gas particles. So what you're doing now is you're taking all those gas particles in a corner. You're separating them in a corner. So the gas particles take up some space. Hey, chudandira. So let us say these are your gas particles. What did you do? You separated all of them in a corner or something like this. Hey, shrink. They become like that. Ante they are occupying some space. You're understanding? Hi. Sajid Ahmed, hi. So, as compared to the container, andariki, if you're seeing the comparison with container, the gas is occupying some space. Kani, we don't want that. Idu, sir, because we cannot take the risk. The gas volume is the volume of container. Kani, there should not be the volume of the gas itself. You're understanding? Sir. Ante, in your ideal gas, if this is the container, andariki, if this is a container and your gas particles are separated at a corner, chuskondi. Negligible space kada? Yes. Pudu, these molecules will spread into the entire container. Chuskondi. This is the first postulate. Try to understand the difference between your real and ideal gas. The second postulate, andariki. Gas particles continuously moving kada. So in motion law, there is a chance that they will hit one another. You're understanding? There is a chance that they will hit one another. Ante collisions ra, collisions. Ide kada. Hitting ante enti sir, collisions. So there are two types of collisions. Andariki. Number 1. Gas collisions, leda glass to wall collisions ra. We are assuming that all the collisions are elastic and enti ra. There is no energy loss. You're understanding? It is actually not possible. You're understanding? It's a very different assumption that we are taking from our real gases. Jagrata, vinandi. Ante your gaseous collision must be elastic. Ante enti ra, your energy between the collision should not be lost. Ante enti sir, ante your total energy of the gas should be constant, which is not possible at all. You're understanding? Sir, next postulate cheppandi andariki. You will simply say that postulate number 3, the potential energy. The potential energy of gas is equal to 0. Potential energy equals to 0 ante enti ra? That means the entire energy of the gas. Jagrataga vinandi. You only have two types of energies kada, kinetic and potential ra. Dentlo kuda your potential has become 0. Ante enti? The only gas energy that has is in the form of kinetic energy. Andariki ide kada? Yes. Ante enti ra? Your total energy is just in the form of kinetic energy. But chudandi, it has two different meanings. Andariki each and every point could be asked as a separate question ra. You are understanding? each and every postulate could be asked as a proper PYQ. Okay. What do you mean by this, sir? Your potential energy is zero. And there are two conclusions. Choose code. First conclusion is this. The first conclusion is there is no interaction between the molecules. Potential energy, you take the spring, pull it. Interaction happening, ra. There is no interaction. Okay? No interaction between molecules. This is the first point. What next, ra? Me next point lo, your total energy is in the form of kinetic energy. Elastic and TNT, that means no energy loss. You understand? No energy loss during collisions. There you go. It could be a proper question, Ra. Which of the following statements are correct? Not correct. Which of the following statements are not correct for a gas? Ideal gas. Point number 1, no energy loss during collision. Option number 2, no interaction between molecules. Option number 3, total energy in the form of kinetic energy. Option number 4, some garbage. That fourth will be the answer because all three are correct. Hey, try to understand, Ra. These are the postulates. You must be very well equipped, Ra. Well equipped, and you must be by hearting all these things. It must be on your fingertips. Yes. Next, andariki. Random motion. There you go. You are understanding? Random motion. Random motion is your gas molecules, they are not following a specific path, not following any equation. Okay? Not following any specifics. Yes. IP sessions are to be done, Ra. Don't worry, okay? Don't worry. IP questions are to be done. And Yes, I am understanding. We will take. Don't worry. We will take by your IP. Sorry. Next point is between your collisions and TNT. Your collision time and it is almost same for everybody. Your collision time is negligible in TNT, sir. Try to understand. Choose code. It actually need not be specified. Kani. In your cases, in your gases collisions, the distance between the two gas particles is very less. Kabatti, the time required to travel, it is also very less. Time takwa unte, you have to specify this condition already. Student, if this is your gas molecule, ide enter the distance between them, kada? Yes. So whatever time, idigo, understand all of you. So whatever time, whatever time you require, choose code. Whatever time you require to go here, let us say that time is capital T, Ra. Understanding? So in capital T time, the particle went here, and the collision happened. Our collision time is small t. That means your small t is much less than capital T. Here you go. You are understanding? Current electricity, we discussed something known as your relaxation time. A relaxation time and TNT, sir. The time between collision of any two adjacent electrons ante me relaxation time. Yes. Next, when we are doing the analysis, we want the molecules, we want, yes, that's the same. No interaction, potential energy becomes zero. Your point I'm covering. When we want the entire gas equations, చూసుకోండి, what happens is we don't want the gas molecules to stop. ఇదే కదా, we are assuming a system రా. Hey, I am assuming a system అందరికి. ఇదే నా system ఉంటే I want continuous motion of the gas particles రా. Everywhere, okay? At all the time intervals, I want the uniform motion of gas particles at every time. చూసుకోండి. Can you see? No gas molecule is at any place. అంటే density చూడండి రా. Your equal gas molecules exist in equal places. ఇదే కదా? Yes. It is my ideal scenario. చూసుకోండి. You will not find any empty space రా. Is there any empty space? No. అంటే you take any region, you will find same number of gas molecules. కానీ మీ real case లో it does not happen like that. Gas particles, they either collect at one place. అంటే ఏంటి రా, they are heavy ఉంటే gravity acts on them. ఇదే కదా, gravity acts on them. కాబట్టి here will be less number of molecules రా. కానీ here this is your real scenario, this is your ideal scenario. ఇదే కదా, this is the difference. ఇదే మీ డిఫరెన్స్ రా. సిక్స్త్ పాయింట్ అంటే there is no effect of gravity on gas molecules. అర్థమైంది? There is no effect of gravity on your gas molecules. And last topic ra, seventh one. Your gases are ideal kada. We will be using your ideal gas equation. Okay, your equation PV is equals to nRT should be లేదా should hold true. Finished. Got it. So these are the 7 postulates. You must remember them one by one by heart. అర్థమైంది కదా? Yes. So once you are done with them, we will move to the kinetic theory. And I want all of you to understand these things. Okay? It could be asked, which of the following is not an postulate of your ideal gas theory? Let us discuss something known as your partial pressure relationship. Okay, partial pressure. Dalton's law of partial pressures. I think I forgot that. What do you mean? What do you mean? What do you mean? చూసుకోండి. మూడు chambers రా. Okay, in these chambers, let us say your number of moles of gas are in 1. ఇక్కడ వచ్చి there are in 2, they are in 3. ఇదే కదా. Let us say pressure is P1, pressure is P2, pressure is P3. volume is V1, volume is V2, volume is V3. Now, the case is if I am mixing all these three gases, what will happen? If I am mixing all these three gases, what will happen? Sir, your net pressure is equals to P1 plus P2 plus P3. Option A. Option B, sir, your net pressure is equals to P1 P2 plus P2 P3 plus P1 P3 divided by P1 plus P2 plus P3. Option C, sir, your net volume V-net is V1 plus V2 plus V3. D. V-net cover here, you try to take this and then this is your V-net. Can anyone if you tell what will happen? What will happen? What is the correct answer? Cheppandi. I'm back. Okay, you're back. I'm also back. Everybody is back. Nobody is in front. A, B, C, D. A, B, C, D. A, B, C, D. Cheppandi, which is the correct one? Option A is correct. Option B is correct. Option C is correct. B is correct. Sorry, I'll remove the wrong options. Okay. Number 1, this is wrong. Number 2, this is wrong. Number 3, this is wrong. Ante, this already is wrong. Understanding? Nothing of them is correct. Try to understand. Try to understand all of you. What did I say? What did I say? What did I say? You are having try to understand. V-net and ఏంటిరా? Volume. What volume? You are transferring these gases రా. ఇదే కదా. Try to understand. If your volume V1 is 10 liters, V2 is 7 liters, V3 is 3 liters. ఎంత సార్? 10, 7, 3 అంటే 20 liters కదా. 20 liters. కానీ if I am transferring all these gases into another chamber రా, and the volume of that chamber V is equals to 50 liters. చెప్పండి. What do you think will be the volume of the total gases రా? What do you think will be the volume of total gases? So you say, sir, 10 plus 7 plus 3 is equals to 50. Is equals to 50. No. In gaseous case, you will not say. You are understanding, in this case, when you are transferring all these three gases, ante all these three gases came into this chamber. Yes. What is the volume of this chamber? 50 liters. Ade, close your eyes and tell the volume of the net gas is 50 liters. Irrespective of this 10, 7, 3. Does not matter. Understanding? You are understanding? We cannot say anything, anything. We cannot say anything about the pressures and the volumes. You are understanding? When you are transferring the gases into another chamber, can't say anything. Understand? This is the biggest problem the students do. In your partial pressures, they simply say that P-net is P1 plus P2 plus P3. No, not in this scenario. Okay? Mari, where to apply? I will tell you. Choose one. If you have a chamber, student, you are not transferring, you are not doing anything. Ready go. Ide, me chamber kada? Yes. So, in chamber lo, let us say you have multiple gases already added up. You are understanding? you have multiple gases that are already added up andariki. So for example, let us say red color gas and your gas A is there. Okay, yes. The same time, white color gas and let us say it's gas B. Okay. Next, green color gas. Okay. Gas C. Digo, how many gases are there? 3 gases. Next. Visualize, these are the gas molecules. Understanding? These are the gas molecules. How many types there? 4 types of gases are there. So let us name them andariki. So white color gas kada. So white color gas ante gas A. Idigo. Your pink color gas ante gas B. Here. Okay. Yes. What next? Your blue color gas ante gas C. Here. And what about next? Next is your red color gas kada. Yes. So let us say this gas is D. Idigo. You have 4 types of gases. Let me just circle it out. 1, 2, 3, 4. You're understanding? Sir, what can you say is each chamber low total pressure is equals to pressure due to all 4 of them. Try to understand. You're understanding? Sir, so you will simply say, sir, total pressure inside the chamber is equals to pressure of gas A plus pressure of gas B plus pressure of gas C plus pressure of gas D. There you go. You understanding? The gaseous pressure, independent pressure ni choose, you will say that they are the part of the total pressure kada. Yes. Kabatti, you will simply say PA ante partial pressure of gas A, B, C, D. They are partial pressures. You add them up in a container. You are understanding? You cannot say when you are changing the containers. In a single container, your partial pressure will be something like this. Temperature is same. Container, your temperature is same. Your volume is also same. Temperature volume fixed. Your gas constant R is also fixed. So P low, the only variable you have is pressure and number of moles. You are understanding? Pressure and number of moles. So you simply say, sir, ideal gas equation PV is equals to nRT. So your P should be equals to nRT upon V. Ante your N total, RT total should be divided by V total. Should be equals to N1 R T1 by V1 plus N2 R T2 by V2 plus and so on and so forth. You are understanding? You are able to understand? At the end, sir. What is N? What is N? What is N1? What is N2? What is N3? What is N4? Can anyone of you tell me, Ram? So, hey, all of you try to understand. What will you say here is, sir, your total number of moles NT kada? Yes. RT, R constant, R gone. Temperature kuda and volume kuda, they are same kada? So you will simply say, sir, they are also gone. There you go. Gone. And your total pressure is equals to, Chapandi, your pressure due to first gas, second gas, third gas, and so on and so forth. And then total number of moles N1 plus N2 plus N3 and so on and so forth. ఇప్పుడు నాకు ఇండిపెండెంట్ ప్రెషర్ కావాలి రా. ఇండిపెండెంట్ ప్రెషర్ అంటే ఏంటి సార్? ఓన్లీ ప్రెషర్ డ్యూ టు ద ఫస్ట్ గ్యాస్ ఏ లేదా ఓన్లీ ప్రెషర్ డ్యూ టు ద ఫస్ట్ సెకండ్ గ్యాస్ బి. ఇదే కదా అంటే పార్షియల్ ప్రెషర్స్ కావాలి. పార్షియల్ ప్రెషర్స్ కావాలంటే యూ విల్ సింప్లీ క్యాల్కులేట్ ద మోల్ ఫ్రాక్షన్స్. మోల్ ఫ్రాక్షన్స్. వాట్ ఈస్ మోల్ ఫ్రాక్షన్స్ సార్? Hey, chemistry you have studied mole fractions kada? Yes. So you will simply say that partial pressure of gas A is directly proportional to mole fraction. I should something like that. You understand? Similarly, partial pressure of B directly proportional to mole fraction of B. What is mole fraction, sir? I don't know. Okay? I don't know. So on so forth. Ippudu cheppandi. What will you say, sir? Your total pressure should be equals to P1, P2, so on so forth. You are understanding? Something like this. They will say total pressure ante P0. Are you understanding? Ante enti sir? Your total pressure is equals to P naught. Ide kada? Yes. Directly proportional kada. Let us take some constant ra. Sir, PA is equals to some K into mole fraction of A. Similarly, PB is equals to some K into mole fraction of B. And so on so forth ra. Total pressure P naught తీసుకోండి. Substitute. Sir, total pressure P naught అంటే K into mole fraction of A plus K into mole fraction of B and so on so forth ra. ఇదిగో. Take K common. You are left with mole fraction A plus mole fraction of B plus so on so forth. Hey, you add mole fractions. You get 1 అంటే 1 ra. So sir, P naught అంటే total pressure, K into 1 అంటే your K value should be equals to P naught. ఇదిగో. That means you get the formula. Your partial pressure of A is equals to total pressure into mole fraction of A. Good. Similarly, your partial pressure of B is equals to total pressure into mole fraction of B. All these things. You want me to elaborate more? I'll elaborate also. Choose one. Your mole fraction is nothing but number of moles upon total number of moles. Yes. So you will simply say, sir, partial pressure of A is equals to total pressure into number of moles of A divided by sum of number of moles of all gas elements. You are understanding? And so. I hope you are understanding, Ra. So with that being said, let us take a question on partial pressures only. The question is, a container at 30 atm pressure, okay, 30 atm has 2 grams hydrogen, 16 grams helium, So let us quickly calculate the mole fractions ra. ఆ కోసం మీకు number of moles కావాలి కదా. 2 gram hydrogen అంటే number of moles of hydrogen is equals to 2 moles రా. Atomic mass 1 ఉంటుంది కదా. 2 grams hydrogen అంటే 2 moles of hydrogen. Similarly చెప్పండి. 16 gram helium రా. Atomic mass 4. 16 gram అంటే number of moles of helium is equals to 4. 32 gram oxygen రా. Oxygen atomic mass ఏంటిరా? Atomic mass is 16. 16 అంటే your number of moles of oxygen is equals to 2 moles. ఇదే కదా. And lastly చెప్పండి నియాన్ అంటే ఇది కూడా atomic number 10, atomic mass 20 అంటే 40 grams of 2 moles of helium is there. So number of moles of helium is equals to 2. ఇది total number of moles అంటే how much రా? So it's 10. So total number of moles is equals to 10. ఇదే కదా. ఇప్పుడు calculate రా. Calculate the total mole fraction. Mole fraction of hydrogen is equals to 2 upon 10. Similarly, mole fraction of helium is equals to 4 upon 10. Yes. చెప్పండి ఆక్సిజన్ గురించి. సో మోల్ ఫ్రాక్షన్ ఆఫ్ ఆక్సిజన్ 2 upon 10 అంటే 1 upon 5 అని ఆటోమేటికల్లీ చూసుకోండి. 1 upon 5, 2 upon 5, 4 upon 5 ఆల్రెడీ వచ్చింది రా. రిమైనింగ్ ఇట్ మస్ట్ బి 1 upon 5 ఓన్లీ. సో మోల్ ఫ్రాక్షన్ ఆఫ్ హీలియం is 1 upon 5. ఇదిగో finished. How much pressure, sir? How much pressure? Hey, 30 atm kada. Substitute. So partial pressure of hydrogen is equals to P naught into mole fraction of hydrogen. 30 into 1 by 5 అంటే 6 atm. Finished. వచ్చింది కదా. రైట్. సో ఇప్పుడు చూడండి రా. 1 upon 5 అంటే 6. 2 upon 5 అంటే 12. 1 upon 5 అంటే 6. 1 upon 5 అంటే 6. Finished. You can do it by this works. Okay, 6, 12, 6. Very okay. Now, let us talk about your speeds. Okay, kinetic theory of gases law. When we are talking about a gas molecule, the gas is in a container. Ide kada? Yes. How weight ra? How weight? Number of moles hydrogen 2. ఇదే కదా. హీలియం 16 gram అంటే హీలియం అటామిక్ మాస్ 4. 16 upon 4 is 4. ఓకే. 32 gram ఆక్సిజన్ అంటే 2 mole of oxygen. 2 plus 4 plus 2 plus 2 రా. It is 10, not 8. 2, 6 plus 4, 10. Sir, try to understand. Now, let us take one example and then you all try to visualize it. Okay, try to visualize it. Gas check. దీంట్లో you have a lot of gas particles అందరికి చూసుకోండి. So these are my gas molecules. Wasting time, sir. You are wasting time. Yes, just one. The biggest problem that we have is we have the gas molecules going in all the directions. Just you are understanding. We have the gas particles moving in all different directions, and there is not one. There are trillions, quadrillions of gas particles. Trillions of them. Trillions. మరి ఇప్పుడు ఎనర్జీ గురించి చెప్పాలంటే is it possible? Half mv square for each and every single gas particle. Possible? Not possible. You are understanding? Not possible. Mari em cheyali sir? Try to understand. We defined a terminology. Terminology number 1 is your RMS speed. Oh my goodness. Very good. RMS speed ante enti sir? In your RMS speed, it is purely linked with your energy relationships ra. Okay, your energy relationships ante enti? I'll tell you, jagrataga vinandi andariki. If I tell you to find the total kinetic energy of the gas, what would you write, sir? Sir, half m v1 square plus half m v2 square plus half m v3 square and so on and so forth. Ide kada single what a type of gas molecule unte mass of each molecule will be same. You're understanding? Mass of each particle of gas will be same. Hydrogen unte every gas particle has the mass of one atomic mass unit, AMU kada. Yes, kabatti m taking constant. So what do you do? Sir, kinetic energy is equals to this kada. So kinetic energy is equals to half into m into cheppandi. What is it? 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 ఇప్పుడు V1, V2, V3, V4, they are not same, bro. You must add them. Ante sir, V1 square plus V2 square plus V3 square plus and so on and so forth, Pn square. Ide kada. You are seeing something? The velocities are getting squared and added up. You are understanding? Squared and added up. But sir, why are you taking so much of different speeds, sir? Take one I should say average speed. No, sir, one representing speed. And instead of all these things, I only want a single speed. Mari ela calculate cheyali, sir? How do I calculate, sir? Let us say that constant speed, చూసుకోండి రా, V1, V2, V3, V4, Vn, so complicated kada. Yes. So instead of all these V1, V2, V3, V4, V5, let us take a single speed squared ra. Ante enti? Let us say, sir, that speed is V squared. Ante instead of V1 squared, write V squared. Instead of V2 squared, write V squared. Instead of V3 squared, write V squared. Instead of V4 squared, write V squared. Everywhere. Ide kada. V square ante the equivalent speeds of all of your V1 square, V2 square, V3 square, V4 square. Ardhamaidi andariki? Yes. Now the simplification has become much more easier for me. Chuskondi. How will you do it, ra? Sir, how many speeds are there? N speeds. Ante V square, V square, V square, V square. How many times? N times. Ante NV square. This V square, this V. It's a special type of speed kada. Yes. Let us try to understand what this V is, ra. So how did it come, sir? You simply say your NV square is equals to V1 square plus V2 square plus so on up to Vn square. Ide kada. Hey, send that and that side, ra. So your V square should be equals to V1 square, V2 square, V3 square, hey, so on up to Vn square divided by n. Now square root తీసుకోండి అందరికి. Now take the square root. Ante enti ra? Your V should be equals to root of V1 square, hey, V2 square, hey, V3 square and so on up to this speed is the equivalent leda monitor leda the resultant leda the constant speed. You can replace the speed of every gas molecules and calculate the kinetic energy. You are understanding? So what do you name it, ra? It's root, square and mean. Ante root, mean, squared, RMS, VRMS. So this is your VRMS. Value is root of V1 squared plus V2 squared. All this divided by. Now, when I was doing this calculation, what did I say? Every gas molecule has different types of speeds. Yes, every gas molecule has different types of speeds. So if you want to replace it, replace cheyali kada. Yes. So if at all you want to replace it, you are replacing it with a speed V. And this speed is known as VRMS, all this discussion. What is the value of this V, ra? What is the value of this V? So to observe this value, we need to observe all the quadrillion particles in the gas kada. Not possible, ra. Humanly not possible. Mari em cheyali? You don't have to do anything. Scientists have done. Scientists have done. They said that, try to understand. The V speed, the common monitor equivalent speeds that you will be replacing. This equivalent speed depends on the temperature and the molecular mass of the gas. Try to understand. You are understanding? Yes. This speed, VRMS, is dependent only on the temperature and mass of the gas. So So they said that your VRMS is equals to root of 3RT divided by M. This is one of the most important results that you have. Finished. If you are done with it, your entire thing has been completed. You understand? Hey, try to understand, Ra. You are understanding? So your VRMS is simply equals to root 3RT upon M. M ante mass of the gas. Mass of the gas, kada? Yes. Okay, sir. In case lo, your M is the mass of independent particle kada? Yes. What is this? Ra? This is the molecular mass of the gas. Try to understand, all of you. Try to understand. I'm telling you. See, if you have n number of moles, if you are understanding, not understanding, I don't know, Ra. If you have n number of moles, hey, M is a single particle ki mass, Ra. And such, there are n moles. Yes. How do you write the moles, Ra? Sir, you write number of moles n is equals to given mass by molecular mass. What is given mass? What is given mass? Given mass is M. M. Yes. Sir, your given mass of the gas is total M divided by molecular mass is capital M. So, you write simply small m is equals to n into capital M. You write this value of M over here, and let us try to visualize it. Okay. So, your kinetic energy is half into small m. Small m ante enti n into capital M. Ide kada multiplied by V1 square plus V2 square and so on and so forth. Yes. Ee mottam speeds ni we have replaced with this ante VRMS. So you simply say, sir, instead of all this, we are writing VRMS whole square. Gone. Ante you will simply say half into n into m into VRMS whole square. This is the total kinetic energy. Andariki chuskondi. Chindi kada? Yes. So now what you do is you substitute the values. Half into n into capital M into VRMS whole square. What is the value of VRMS? They told us root 3RT upon M. Ante root 3RT upon M whole square. Root gone. Hey, choose kondira. Ante entira half into n into capital M into 3RT divided by capital M. M gone. Ante 3 by 2 n RT. This is the total kinetic energy of the gas. You got it from your RMS speed formula. If you are remembering, good. Not remembering, let it be. Not important. Sir, I remember something. NRT. PV is equals to NRT. PV is equals to NRT. Yes. So instead of NRT, PV raskondi. So your kinetic energy is 3.2 PV. Gone. Chindi. Okay. Done. Done kada? Done. So you are well equipped with your kinetic energy formula. 3 by 2 PV, leda 3 by 2 NRT. Understand? Yes. Now student. We do have some. This entire discussion was started from your RMS speeds kada, speeds leda kinetic energy of the gases. We have two more types of speeds. First one is your V average and average speed. So first discussion that we have is your average speed. Understand me? Yes. Try to understand everybody what I'm telling to you. This gas energy, whatever we have written over here, Jagrataga Vinandi. You will simply say that this energy, half mv square, what is it? Kinetic energy. When the gas molecules are simply moving. Kani, when you see it from a rotation perspective, if this gas is rotating also and moving, it has two types of energies. Kinetic or rotational. What is the formula for rotational energy, sir? Half I omega square. I ante moment of inertia. Omega ante. Understand? But I did not include rotation. Try to understand. I only included translation kinetic energy. Ante only motion energy. This is 3 by 2 NRT. వచ్చింది కదా? సరే. The second type that I have is your average speed. చూసుకోండి, average speed అంటే ఏంటి సార్? మీ average speeds we only consider about the speeds, not the directions. Understand? We only consider speeds, not the directions. చూసుకోండి, your average speed V average is equals to mod of V1 plus value divided by total number of molecules అంటే n. ఇదే కదా? You also don't have to do it. Scientists have done it. They are observing every single particle, adding the speed. Too much headache. Scientists have done it. They told you that average speed, V average is equals to root of 8RT divided by pi into n. So this is the average speed. Me andariki, hey, you must remember this formulas. This is chala important. You are understanding it has been asked. Last 10 years low, there are 8 PYQs from these concepts only. From your average speed, most probable speed and your RMS speed. Vachindi kada? Yes. The last discussion that you are left with is your most probable speed. What is most probable speed, sir? Cheppandi okasari. Your most probable speed ante it is the speed of the gas molecules. What gas molecules, sir? When the scientists observed all the particles, out of it, a majority of them had a same speed. A speed ni a most probable speed antaru rade. You are understanding? Ante you simply say, sir, what is your most probable speed? It is speed possessed by maximum number of gas molecules. Maximum number of gas molecules. How to find it? Didi kuda. Coincidentally, this is also dependent on temperature. Temperature only. Okay. So the value of the most probable speed VMP. Cheppandi. Mass of the gas. Vachindi kada? If you are asked to find the ratio, how will you find it? The ratio goes, you will simply say, sir, V average is to V RMS is to V most probable should be equals to remember the ratio. Okay, sir. Good, very good. Root 2 RT upon it. So this is the ratio. Andariki. Yes. Let me see if there are some PYQs or not. There are a lot of PYQs on this topic. This one, it has been in 2023. What temperature? Heating. Look at that. duration will be maybe half an hour or 1 hour. Maybe half an hour or at max 1 hour. It will be finished. 10 to 10:30. Anywhere in between them. We're not going into the derivations and all, okay? Exam point of view nunchi, whatever is important I'm taking. You must take ratios only, okay? If you're taking the ratios, it will be done. I'll be back in 2 minutes. Change. Done? Not done. Sir. So your RMS should RMS speed increases 3 times. If your RMS is there, Leda, your average speed is there, Leda, your most probable speed is there. Condition and same. You understand? Instead of RMS, if he is asking you about your most probable speed, Leda, average speed, nothing changes, everything remains the same. Every constant is getting cancelled out. So let us say your V2 is root of 3RT upon M kada T2. Similarly, your V1 is equals to root of 3RT1 upon M. The ratio తీసుకుంది. gone. Understand? Average speeds unte root 8 RT gone. Understand? You can simply say your V2 upon V1 should be equals to 3 kada, 3 becomes 3 times, and the root of T2 upon T1 should be equals to 3. That means your T2 upon T1 should be equals to 9 ra. That means your T2 should be equals to 9 T1. Idigo. Finished. 9 into T1 value enti sir? Minus 50. Ante 273 minus 50 cheskondi. You are getting as 223 Kelvin. That means 7, 9, hey, am I doing correct or am I doing mistake? Minus 50 అంటే తెలుస్తుంది కదా. I think I'm doing calculation mistake. Calculation. There you go. So your 9 3s are 27, 2 9 2s are 18, 2 20, 2 is there, 9 2s are 18 and 20, 2007. Kelvin. Hey, correct. Oh. One mistake. Correct only, Ray. Hey, correct only, kada. So your T2 divided by T1 should be equals to 9. I thought it is inversely proportional to temperature, directly proportional. So your T2 should be equals to 9 into T1. So 9 into T1 value cheppandi okkasari. 223 Kelvin. Kelvin ra, convert into degrees Celsius. Remove it, okay? Sorry, whatever it's there. Okay, you can do it. Increases by 3 times or increases to 3 times, right? I don't know. I think I did not read the question properly. Give me a minute. Okay. By 3 times. Ambiguity in the question itself, okay? Hey, you do one thing, okay? Increases 3 times. By 3 times not there, right? It's not a NEET question, it's my question, okay? Take it as my question. Subtract. Hey, remove the option, ra. Remove it. 2007 is the right answer, okay? Hey, question, see the question, ra. See the question. Increases 3 times, kada? Anyways, done. Alright. So now let me just quickly talk about the energy of the gas. Energy and kinetic energy. You are understanding? Energy and kinetic energy. Sir, your chat section is, it is. Sir, చూసుకోండి, let us directly talk about law of equipartition of energy, write about the energy values and finish the discussion. Okay, sir. Now, let us talk something about your degree of freedom, the law of equipartition of energy. Oh my goodness. This is the most important part of the discussion. Law of equipartition and entira. Your law of equipartition of energy tells us, discusses about the distribution of energy in different atoms, molecules. Yes. Our law discuss chesi mundu, we will want to discuss something about your degree of freedom. What is your degree of freedom, ra? Degree of freedom ante F. ఇదే కదా. We'll have to discuss something about your degree of freedom. చెప్పండి, what do you mean by degree of freedom? Basically, you can simply say, hey, idigo, degree of freedom is nothing but the dimensions in which the particle can move. Ide kada? Yes. Try to understand. There are types of degree of freedom. Hey, moodu rakalu unnai ra. The first one is your linear molecules. Not linear molecules. Translation, rotation kada. Linear, non-linear, they are different cases in which we have to study. Degree of freedom ante the first type is your translational degree of freedom. Next is your rotational degree of freedom. Next is your vibrational degree of freedom. Go. Here you go. Vibrational. We will not talk about it, okay? It's your syllabus also, your questions also. They don't talk about the vibrational degree of freedom. It will be given to you. And this vibrational degree of freedom depends on the temperature. There are much more detailed analysis and the formulas for this. It's there for GE advanced, okay? Not for you. Chudandi. So we'll only talk about your kinetic and rotation. You understand? Yes. If your molecule is simply a point molecule tells Andriki. Yes, yeah. Total degree of freedom is the addition of all of these, but there are different types of it. Just go. May translation motion in the interior. If you have a point of gas molecule, leda. Right. Understand it. Okay, understand. Sorry. So if you are having a point mass and spherical, chinna sphere తీసుకోండి. It can move along x-axis, something like this. Okay, along x-axis, 1 degree of freedom వచ్చింది. Leda it can move along y-axis. Second degree of freedom వచ్చింది. లేదా it can move along z axis. Third degree of freedom వచ్చింది కదా. Yes. There is one more way we can do it. We can take out a chamber. A chamber we will talk about the relaxation time, change in the momentum and pressure conditions, all of those things. I don't want to go into all these things. Okay. Sorry. We will talk about this only. చూసుకోండి. So you will simply say that there are 3 translational. Yes, 3 translational degree of freedom. What about rotation? What are the maximum number of degree of rotations? Cheppandi. Can you tell me? What are the degree of rotations? You're back. I'm also back. Everything is back. Okay. The syllabus is back. Exam is back. Subjects are back. Okay. I'm kidding. Okay, I'm kidding. Cheppandi. Hey, what is rotational degree of motion, Your rotational degree of freedom is senseless for your spherical objects. You understand? Your rotational degree of freedom is senseless for your spherical objects. Spherical objects ante monatomic molecules. చూసుకోండి. So let us shift it a little here. Translation వచ్చింది కదా. Yes. Hey, I don't want vibrational. We're not discussing on vibration. Vibration, you keep it. Okay. So let us talk about your rotational degree of freedom. Right, చూసుకోండి రా. Right, చూసుకోండి. If you have monoatomic అంటే ఏంటిరా? సింగిల్ ఆటమ్ ఉంటే మీ monoatomic atoms కోసం your degree of freedom of rotation is 0 రా. ఎందుకు సార్? Because if you have a sphere, it is rotating, not rotating. Same రా. Same. You understand me? Sorry, what next, sir? If you have a linear molecule, we're not talking monoatomic, diatomic or triatomic. Me linear molecule unte linear ante something like this. Chusukondira. It could either rotate like this or like this. You're understanding? Rendu unde kada? Yes. Yeah, it's rotating something like this also, but that is not significant. You're understanding? You will not see it. Diatomic ra. Don't say diatomic ra. CO2 చూసుకోండి అందరికి. CO2 అంటే ఏంటి? It's a diatomic. Triatomic. Oxygen, carbon, oxygen. But it's a linear molecule. Molecule linear unte, it has only 2 degrees of freedom. You're understanding? Don't say diatomic. Sorry. Linear molecule unte, you will simply say, sir, degree of freedom of rotation is equals to 2. Non-linear molecules kosam, there are 3 degrees of rotation. Good pet. Okay. Sorry. For non-linear molecules, your degree of freedom of rotation is equals to 3. Here you go. So you have 0 for your monoatomic and spherical molecules, atoms, does not matter. Directly 2, okay? It's not 1, directly 2. For your linear molecules and 3 for your non-linear molecules. అర్థం వచ్చింది కదా? Yes. ఇప్పుడు చూసుకోండి. Law of equipartition of energy. ఇదే కదా? We are talking about the law itself. What does it say? The law of equipartition of energy simply says that every hey, I should not say direct every, for every molecule. Okay? For every molecule, లేదా atom ra. Okay? For every single gas unte unimolecular gas. Example, hydrogen, helium, neon, argon, krypton, xenon, radon, all this. Okay? For every atom, లేదా molecule of gas molecule. CO2, H2O. H2O is gas. It's gas also in vapor form. You understand? Yes, H2O, SO2, N2O, NO, NO2, NO3, all these gases are. Anyways, for every gas, atom, లేదా molecule, చూసుకోండి, each degree of freedom, okay, each degree of freedom is associated kinetic energy. ఇదే కదా? With only no potential energy ra. This is the beginning of the lecture. Assumptions kada? No potential energy. With kinetic energy is equals to 1/2 into K into T. What is this case of K ante Boltzmann constant. Gurtunda 1.38 10 to the power minus 23 ra. Boltzmann constant. ఇదిగో. With kinetic energy. Hey, I should not. K only. Yeah, you might say that this is also K. K gone. Okay. This is kinetic energy. This much. And if your degree of freedom for for 1 degree of freedom, you have this much. If degree of freedom is 2, you have 2/2. Degree of freedom 3, 3/2. Degree of freedom 4, 4/2. Degree of freedom 5, 5/2. Degree of freedom 6, 6/2. Degree of freedom F. So total kinetic energy becomes F/2 into K into T. చూసుకోండి. This is for molecule or atom ra. Finished. You're understanding? Molecule or atom. What is the relationship between K and R? I told you R is equals to K into Avogadro's number. ఇదే కదా? Yes. So if you have n moles ra, మీ దగ్గర n moles ఉంటే what will you say? చూసుకోండి. For n moles, you will simply say the kinetic energy of the gas is given as F/2 n. It will be R and it will be T, and in this case you must take the value of R as 8.314. This is the understanding. Choose joules. అర్థమైంది అందరికి? యూఆర్ అండర్స్టాండింగ్? 9:46 కదా? you remember we talked about the kinetic energy, 3 by 2 nRT. Gurtunda 3 by 2 nRT, but that's only for the translational motion. Chuskondi. What is the degree of freedom, ra? Your translational motion kosam 3 degree of freedom untundi kada. Yes. So you simply say, sir, if your gas is only doing translational, chuskondi, only for translation, only for translation, what will you say? You will simply say kinetic energy is equals to F by 2 nRT. What is the value of F? Your translation kosame, your F value is equals to 3. Okay. I'm more cool. So F by 2 and 3 by 2 nRT. This is the kinetic energy of translation. You are not including rotation. You are understanding if it is rotating, then its kinetic energy will be half I omega squared. I and T is moment of inertia. You are understanding? It becomes too complicated. Kavati. But from this formula, hey, for rotation, only for rotation. For rotation, here also you get cases. Cases and T. You have monoatomic gases. Monoatomic. देखा మీ monoatomic gas కోసం kinetic energy is F by 2 కానీ rotational కదా degree of freedom rotational degree of freedom RT రా. But hey, sad like ra, here FR is 0 అంటే rotational kinetic energy is 0 అంటే your moment of inertia is 0. Adhe, the same thing I was trying to say, you are trying to understand. Your kinetic energy of rotation 0 kada, and half I omega square equals to 0. For a single molecule, it's the point size, it is rotating, not rotating. Moment of inertia is 0. Enduku sir? Because distance is 0. You want me to go into physics, half I and T sir, mr square kada? Yes, into omega square. This is the point mass. What is the radius of it? 0. You understand? 0. And the axis of rotation is on the particle itself. Okay. And your R value is 0. What is R, sir? R is the distance of the gas molecule from the axis of rotation. That is 0. Kabatti, you will say that there is no factor of telling about your moment of inertia. You are understanding? Sir, when you go on the next topic at Indira, e case low, you are having one more thing. For linear molecules kosam cheppandi okasari. For linear molecules, your degree of freedom of rotation equals to 2. Ante your rotational kinetic energy is F by 2 into nRT. Dekada ante 2 by 2 into n into r into t. Ante nRT idigo finished. It should be equals to half I omega square. So when you are talking about I, you have to add the total moment of inertia of the gas molecules. 10 to 15 minutes more than completed. Okay. Sorry. And when it's a non-linear molecule, cheppandi. Me non-linear molecule kosam, you will have the rotational degree of freedom is equals to 3. Ide kada? And your kinetic energy is 3 by 2 nRT. Finished. We're not talking about vibrational degree of freedom. Okay. We are not talking about the vibrational degree of freedom due to vibration. No, you're not talking. No, that depends on the temperature. Perfectly depending on the temperature. High temperature and high vibrations untundi kada. So degree of freedom remains high over there also. And that too, if we have a single atom, more atoms, 2 atoms, 3 atoms, 4 atoms, varies. It depends. Okay. It depends completely. Sorry. So with that being said, if you want me to take some questions, we could take it also. Okay. So kinetic energy of the gas has been completed. This is all about your kinetic energy. Okasari you are good with your, hey, we'll be done by 10 Don't ask it. Okay. Okasari you have the information about your degree of freedom. The degree of freedom ante your energy will be there. Once you are good with your degree of freedom, that's it. Your degree of freedom will itself give you everything. Yes. So, sir, I understood. You are telling me that okay, single type of gas kosam ra. Degree of freedom ante enti ra. You have single type of gas kada? Yes. That single type of gas is only doing the oscillations. Leda vibrations, whatever it is there ra. And if your gas is monoatomic, you will take different F. If your gas is diatomic, you will take a different F. But what if you have a mixture of gas? What will you do if you have a mixture of gas? So your kinetic energy equals to F by 2 nRT. Idigo andariki jagrataga vinandi. F ante enti ra? Your F is total degree of freedom. I like the video, all of you. Like it. Hi. Hello. Hello. Anyways. So, when you are talking about a single type of gas, a gas kosame 10 or 10:30 at max, okay? Something like that. Don't worry. Your kinetic energy F by 2 nRT. What is F? Total degree of freedom. For what? Told you, Veda. See, as long as it's a linear degree, right? Translation degree of freedom, I don't have any problem. Why, sir? Because the sphere also, a 2D object also, moving in the same direction, same way. But, when it comes to your rotational degree of freedom, you don't say, Kani, why, sir? Why? Because for your monatomic degree of freedom of rotation is 0. For your linear molecule, it's 2. For your non-linear molecule, it's 3. Mari, how will you decide, Ra? How will you decide what is the degree of freedom? You're understanding? Ante, you imagine something like this. So you have the mixture of gases. In mixture, you do have some other types of examples. Choose hydrogen is there, helium is there, SO2 is there, N2O5 is there. You're understanding? Linear and non-linear molecules are there. Mixture. Now, I want the kinetic energy of the mixture. How calculate? How will you calculate? Cheppandi. So, formula remains the same. Formula will not change. You're understanding? As long as the gases are ideal. That's what I'm telling to you. You're understanding. In mottam discussion kosam, the basic understanding is your gases are ideal. And all those 7 assumptions, the postulates we have told over there. You're understanding? If you are talking about, sir, I have 2 gases. What 2 gases, sir? I have hydrogen and I have oxygen. What will you do? They'll mix. They'll form water. You are understanding? In case low, energy decreases. So when the reaction is happening, activation energy, chemical kinetics, graph, activation, reactant here, products here. If you don't understand, let it be. Let it not interest. Sorry. Now, formula remains the same. Your total kinetic energy is equals to F by 2 into nRT. Problem is, can you find total number of moles? Yes. You can find for sure. Okay, you can find. Kani, what to do with this F? Understand? To find this value of degree of freedom. Yes. To find the value of degree of freedom, what you will say, sir? You simply tell one thing, right? You simply do one thing. What will you do, sir? What will you do? See, your kinetic energy total is equals to 1 plus 2 plus 3 and so on. What is different? Number of moles and degree of freedom are different. Number of moles and degree of freedom are different. And take this, sir. Your kinetic energy is equals to F1 by 2 N1 into RT. Why RT? Temperature, the temperature of all the gases in a single chamber. It's constant, T. Plus, F2 by 2 N2 RT plus F3 by 2 N3 RT and so on so forth. This should be equals to net kinetic energy. Net kinetic energy. What is net kinetic energy, sir? F net by 2 into N net into RT. There you go. RT, gone. What is remaining, sir? Here, 2 also gone, kada? 2 also gone. So what is remaining, sir? Net degree of freedom, net number of moles should be equals to F1N1 plus F2N2 plus F3N3 and so on and so forth. You understand? What is net number of moles, sir? What is net number of moles? N1 plus N2 plus N3 plus N4, so on and so forth. Are substitute. Space is not there. Let us make some space. You shift to this side. You shift up or up. So let us make some space. Visible also. Sorry. So you will simply say, sir, net degree of freedom is F1N1 plus F2N2 plus F3N3 and so on and so forth divided by net number of moles. What is net number of moles, Ra? Gone. This is the net degree of freedom for the mixture of gases. Hey, you are understanding? Not understanding, Ra? Not understanding, sir. What will you do? Huh? Yeah, boy. Okay, you must be very good, huh? And the Ardham Cheskondira, this is applicable when you have single container. A single container low, you are having different gases. Do you remember I asked you a question, Andariki? Do you remember I asked you the question? Choose Kondi. Where is it? This one. Yes. The question I asked you about the pressure and volume. Yes. You said that A and C are correct. I think someone said it in the chat box. Hey, who is here? Huh? Wow. Oh, ho, 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 ho. Hey, who are you, Ray? My goodness. Oh, God. What? I wish you could dedicate your study, Leda. You could dedicate this much of hard work to do something in your exams, He is doing shairi, Ray. Okay. Sorry. Anyways. What words, Ra? What words? Okay. What words? Why? Why? I don't understand, but why? Anyways, so let us continue to the discussion, all of you. To impress someone, huh? To impress someone. Sir, hey, I told you that. If you have a single chamber, multiple gases, you will be doing all that work, okay? all that work and you will be talking about your net degree of freedom and all those things. Okay? I'm not talking about anything of that. Kani, when your different gases are mixed into one single container, ఆ టైంలో మీకు నెట్ టెంపరేచర్ లేదా నెట్ డిగ్రీ ఆఫ్ ఫ్రీడమ్ కావాలంటే వాట్ విల్ యూ డూ? దట్స్ ద క్వశ్చన్. ఇదే కదా? ఎస్ 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 మీకు టెంపరేచర్ కావాలి రా. ఐఎమ్ ఓన్లీ టాకింగ్ అబౌట్ టెంపరేచర్. ఇదే కదా? అందరికి జాగ్రత్తగా వినండి. Yes. You have different chambers, right? Okay. You have different chambers. I don't know how to copy it. Copy, paste. How to paste? Sorry. Let us take some. Okay, and so on so forth. Okay? So on so forth. You have series of chambers. చూసుకోండి అందరికి. ఈ chambers లో you have different types of gases. Okay, you have different types of gases. In your first chamber, you have one type of gas. Take it up. Yes. In second chamber low, you have one more type of gas. And in your third chamber, you have another type of gas. So what we are doing is, we are now trying to mix all these gases in a single chamber. Yes. When you are mixing all the gases in a single chamber, this is your chamber. Let us say, now I am going to give some information. Degree of freedom of this gas F1, number of moles of gas N1, temperature of this gas T1. Degree of freedom F2, number of moles N2, temperature T2. Degree of freedom F3, number of moles N3, temperature T3. Finally, your degree of freedom, I am not commenting any on that. Your number of moles me andarki telusu, N1 plus N2 plus N3 and so on so. Your temperature, let us say that temperature is T net. Andarki ipudu chudandi. Can I simply say, sir, kinetic energy of this plus this ante the total kinetic energy of the gas. So what will you say now? Your total kinetic energy of the gas is kinetic energy of first gas, second gas, third gas, and so on so forth. Cheppandi okasari, what is the kinetic energy of your gas? Chuskondi. Ee gas lo you have all the respective particles kada? Yes. So you have white particles. Hey, you have pink particles. Yes. And at the same time, you have yellow particles also. Degree of freedom F1. Degree of freedom F2. Degree of freedom F3. Number of moles N1. Number of moles N2. Number of moles N3. Kani, they are at same temperature T net. Cheppandi ra. Total kinetic energy ante due to this ra. What is the formula, sir? F by 2 nRT kada? Yes, sir. F by 2. Hey, F1 kada? Yes, F1. Sir, total degree leda total kinetic energy. Cheppandi. What will you say, sir? F1 by 2 N1 R T net. Cheppandi for this gas ra. Sir, F2 by 2 N2 R T net. Here, sir, F3 by 2 N3 R T net and so on so forth. Add all of this, sir. Add. This is my final energy. Yes, this is your final energy, sir. So F1 by 2 N1 R T net plus F2 by 2 N2 R T net and so on so forth should be equals to independent energies before comparing kada before after the చెప్పండి ఈ కేసులో సార్ F1 by 2 N1 R T1 plus F2 by 2 N2 R T2 plus and so on so forth. ఇదిగో what can you take common రా చూసుకోండి R gone. Common PC you cancel out. Similarly 2 gone. What you are left ra? Sir F1 N1 T net plus F2 N2 T net plus F3 N3 T net and so on so forth. Ide kada? Yes. Should be equals to F1 N1 T1 F2 N2 T2 and so on so forth. Idigo. Can you take out T net common ra? Yes. So net temperature F1 N1 2 and 2 and so on so forth should be equals to F1 N1 T1 F2 N2 T2 plus so on so forth. Gone. Here you will simply say, sir, net temperature of the mixture is equals to F1 N1 T1 F2 N2 T2 F3 N3 T3 F4 N4 T4 and so on so forth divided by F1 N1 plus F2 N2 plus F3 N3 ra gone. So on so forth. Ante enti ra? Your temperature of the mixture is summation of Fnt divided by summation of Fn. Idigo gone. Vachindi kada? Did we do it in some other way also ra? In terms of pressure, volume and temperature conditions. Cheppandi okasari. Hey, we did it in pressure, volume, temperature condition also. What was the condition, sir? If you have multiple chambers ra. So you will simply say P1 V1 upon T1 plus P2 V2 plus P2 V2 upon T2 plus P3 V3 upon T3 and so on so forth. It should be equals to P net. V net and T is that V1 plus V2 plus V3 and so on so forth. Hey, I'll write something like this. This should be equals to P net V net upon T net. So V net and T is the addition of all the volumes. So you'll simply say P net into, you want to take it, leave it. T net value cheppandi. So sir, P net into V net divided by net temperature cheppandi sir. Summation of F into N into T divided by summation of F into N should be equals to V1 upon T1 plus V2 upon T2 and so on. Hey, you want to remember? Leave it. No, don't take tension, okay? Don't worry. Don't take stress. I hate stress. Like the video, okay, everybody? Like the video. 10 kada? 10. Sorry. Let us discuss 2-3 questions around. Okay, directly. Let us take some PYQs. Andariki. Do it. Do it. I'll give you 5 minutes of time. No, it is 2025 question. Little twisted one. Patients are good, but what will you do? You imagine a state in which you have given your NEET exam. I exam you got 110 marks only. And with that score, you are telling those quotations in front of the people. What use, Ra? Hmm? What will they do? You know? Sorry. Anyways. Getting it? Not getting it. Hey, there is a terminology, I don't know if you know it or not. It's known as gauge pressure. So your gauge pressure is simply equals to the pressure minus atmospheric pressure. Why, sir? Because in air, we assume that the gauge pressure is 0 atm. You understand me? Yes. So, sir, this is your actual pressure. You are understanding? So, you will simply say that your actual pressure is equals to gauge pressure plus atmospheric pressure. And 1 atm. Your gauge pressure is 11 atm. Kada? Yes. So 11 plus 1 becomes 12 atm. So, this is my pressure. Choose. You had a container. A container lonchi, what did you do? It had some oxygen gas. Kada? Initially, it had some oxygen gas. 18 moles of oxygen gas is there. 18.2 moles of oxygen is there. What did you do? You removed some of it. And you removed this. దాని తర్వాత after you have removed the gas, this is the final situation. చెప్పండి, this is the final situation. మీ final situation లో values చూడండి ఒకసారి. Your pressure has been 12 atm అంటే it has decreased to 12 అంటే beginning pressure don't know. Yes, don't know. Similarly, beginning temperature don't know. Beginning temperature ఈ case I don't know. కానీ final temperature do you know? Yes, 27 degrees Celsius అంటే 300 Kelvin. ఇదిగో. What else? You don't know. PI you don't know. I don't know. I'm also solving for the first time. Okay. So your temperature initial also you don't know. Your final pressure అంటే 12 atm. Your final temperature అంటే 300 Kelvin. What else do you know? Your R value is also given to you, right? So I think you will have to calculate final number of moles. చూసుకోండి. Then we can talk about the moles that have been removed కదా. So n final కావాలి sir. How will you find n final? n final అంటే we can use your ideal gas equation ideal gas equation చెప్పండి. So final situation లో నాకు number of moles కావాలి అంటే PV equals to nRT PV equals to nRT అంటే your n becomes PV divided by R into T. Do you have P? Yes. Do you have V? Do you have final volume? 30 liters. Okay. Final volume అంటే same volume కదా 30 liters. ఇదిగో. This is 30 liters. ఈ volume నుంచి you have oxygen has been removed. Your oxygen has been removed. So volume remains the same. You're understanding? Sir. So your volume is equal to 30. Pressure is 12 divided by R value. ఇదిగో. Temperature value is that. Did you understand? Classic application of what? You remember it? I told you when you are pumping the gas into a chamber, volume remains the same. Even if the gas is adding, volume remains the same. Reverse చేసుకో. If you are removing the gas, temperature is the same. చూసుకోండి. If you are removing the gas, it's confined కదా, volume remains the same. ఇదిగో. Gone. Substitute the values Your pressure into 12 atm. Hey, I don't want pressure in atm, right? It's not SI unit. Convert into pascals. Pascals and Newton per meter. Yes. So, sir, your final condition low, your number of moles should be calculated. Sir, N2 is equals to P2 V2 divided by R into T. Number of moles into pressure 12 into 1.01 into 10 to the power 5. Multiplied by volume is 30 liters divided by R value. It is actually 8.314, but it's for simplification. He told us to take 100 by 12. So this is be 100 by 12 multiplied by temperature 300 Kelvin. Yes, 300. 3 gone. 12 becomes 144. Yes, so 144 into 1.01 into 10 to the power 5 into 10 divided by 1, 2, 3, 4. So 10 to the power 4. Gone. And it is simply 100 into 144 into 1.0. Hey, correct? You can calculate the values of number of moles. Okay. So we are doing some mistake. What is the mistake we are doing? Sorry, it's correct only. Okay. So upon 12, temperature 300, 10 to the power 4, volume at 30. Okay. So you are left with your we are doing some mistake. Are we doing some mistake? Pressure correct agada. Values are correct. 12 atm is the pressure. So volume is your 30 liters. No change in the volume itself. So R value is 8.3. Temperature is around 300. 300 into 8 into 2400. Question is correct or not correct? Question is correct only. Hey. Right, this volume, it should not be 30. It is liters. Liters. Your SI unit of volume is not liters. Your SI unit of volume is meter cube. Meter cube. Meter cube. Ante your 30 liter will become 30 into 10 to the power minus 3 meters cube. Chuskondi, because in 1 meter cube you have 1000 liter of volume. Oh. That's what I was studying. Why am I getting so huge number? Minus 3. Everything will become balanced, right? Divided by 1000. There you go. Gone. So 0 is gone. So it is approximately 144 into 1.01 divided by 10. And approximately 114. 14.4 into 1.01. There you go. You can do it. It is approximately equals to 14 only. Keda? Yes. Hey, mains level. Not too difficult. It's not difficult. It's very easy question actually. Hey, it's a very easy question, not difficult. Okay, it's mains levels, not mains level. JEE mains level is this. Okay, JEE mains level. We have seen more questions. So there you go. You can approximately say it is equals to 14.4 moles. What was the initial number of moles? Initial number of moles at 18.2. What is the final number of moles? 14.4. Subtract 18.2 nunchi 14.4 subtract cheskondi. So it is the 8 and 17, 3.8 moles are gone. Calculate cheskondi. 3.8 moles ante how many kgs? How many grams? How many grams? Grams. Chuskondi. 1 mole ante enti. For your 1 mole you have mass of oxygen kada? Mass of oxygen. Cheppandi. 16 grams. 16 grams kada? Yes. Mass of oxygen Chuskondi. Go to 32. It has given O2 32 Chuskondi. So for 1 mole you have 16 grams. For 3.8 multiplied by 16, you will be getting some mass, okay? Some mass in grams. So, I think 8, okay? Well, carry it. Something like this. And divide it by 1000. You will be getting it. Done. Okay, done. Class is done. Okay, you remember the concept only. Your concept gives huge significance. Concept and DNT, sir. Your initial volume conditions, your final pressure, volume, temperature conditions. You take the difference of number of moles. Whenever the gas is removed, the gas is added, number of moles changes. Okay, you must be very good with calculating number of moles of gas. If you are done, your volume remains the same. That is what I've told you in the beginning slide in TNT. I've told you somewhere here. Hey, where is it? In the beginning of the lecture, chuskondi. Slide number kuda. If you are pumping gas, number of moles increasing, but volume is same. Volume is same. The same application. Reverse it. Number of moles taken out. Volume remains same. This is the key concept. If you are understanding this concept, go finish. Chapter, that question itself is gone. Okay. Sorry. So, your chapter has been completed. I have taken all the things that were required. Okay. Now, Repu will be doing your thermodynamics. Kani will be having 2 hours of lecture only. So, our 2 hours, it's not possible to complete the entire chapter. We'll take half of it and next half of the chapter for the next day. Okay. For the next day. Sorry. So, thermodynamics part 1, part 2, and semiconductors part 1, part 2, your physics is completed. The entire physics is completed. Okay. Sure. Good night, everybody. Good night. Yeah, thermodynamics, semiconductor. Ready chapters? Yes. So, your thermodynamics will be in the next 2 chapters, lectures, and your semiconductors in the next 2 lectures. Gone. Completed. Okay, sir. We'll just terminate it. Good night, everybody. Good night. You are late, brother. You are late. Hey, thoda pahila aana tha, thoda pahila. You won't got the chance. Everything is getting ended now. Okay, no use of spamming, ra. The person is already dead. Okay. Bye. Sorry. Good night. Good night, everybody. Good night.